So I think we are rolling. Alright. Good morning, everybody. It's me, Swinger, and today we are going to work on the stepper screw. I don't know how the fuck do we. I would need another monitor for this to watch the things. I don't have another connector on the graphics card. Yes, this. So what we are going to do today is that in the beginning I will do a bit of redesigning of this. What we essentially need is that we need to scale down the screw. So basically we need this hole to be scaled down, but then I would need to calculate this because this is a bit of tricky in terms of I don't know. Do I see the? I don't think I see the. Here. Yes. No. Where the fuck do I put it? Is this any? Whatever. We can put it here. I don't care about the other things that much. Or maybe here. Maybe here. We can. Yeah. Alright. So how does it look like? I wanna see. Alright, good. What I will say is that we need to calculate this. We need a scaling. Whatever. I'm going to use AI. Hello. What is this? I am interested in scaling things up before down, because I wanna make a model, but the thread in it is a bit loose, so I thought that I would I mean, technically I could calculate this with the calculator just to make sure. First I will do this so I think I don't rot my brain. Checking if alright. So what so we have 100%. If I scale up to I don't know 105, 102, so 1.025, let's say 2.5. So that's because if you know that there's like a bit of mathematics here. So if you scale this up to 1205 and then scale this down to 0.95, then you get a bit less than, so because this is not you don't take the same base that you want to multiply because it is changes. So yeah, I think it would be something along the line of 10, because 105, if you oops, if you times that by 95, that's not going to be 100. You see, it's a bit less, but I think it is pretty good. It isn't that big of a deal. Yeah, maybe I would say it would be still a bit big. Need to be a bit bigger, though not on the edges. So I will have to redesign this because with the screw, the thread is right, the everything is right, or maybe the, oh fuck, I don't know if I can scale down the only one axis. I think I can. Yeah, I think I can only scale down one axis, but then it would be, oh, just having a bit of thought experiment, or making it 11, but then that's also too small. Yeah, because the other one is too small. This is the problem with 3D printed threads. Alright, come on. Oh, this doesn't open for a long time. So what we need here is a, 13. I think we can go down to 12. 13. How big is going to be 13 if I times that? I mean, we have it here. 13 times 0.95. That's 12.35. I mean, that's pretty okay still. So with these, alright, I will need to scale this up to about so this is what is this, 15. So we need to scale up the whole thing. Not this, no, scale, yes, this to I think it was 0.5, so this is 5%. Alright, then we reduce the width back to 12, so, or yeah, so 6, let's go 6.1. Yeah, so it doesn't wiggle that. I mean, we can do it 6, I don't think. Or no, because it will be scaled down, so 13. Alright, 6.5. Alright, fuck off. And what about 12 is going to be too low. 12.9, 95, 11, and that's too low. So yeah, this is needed. Boom. Boom, what up? So around here. Supposed to be okay. I'm gonna mirror this to the other side. I mean, first I'm going to delete this. Going to mirror this to the other side. Okay, we are nice and round. All right, and we will be able to somehow reduce this. Okay, so we take the, oh, I didn't upload it. This, alright, override, fuck off, quick carriage, okay, and we want to scale this bad boy down, scaling in Z is the blue, we don't want that because we want to keep the thread pitch. We want this to be uniform scaling, no, fuck that. 95%, this is also 95%, and this way I think I made a mistake. Yeah, I think I should scale up the whole thing. Yeah, I think I should scale up the whole thing. Yep. Okay, so go back. Yeah, because it reduces in width. Yeah, so take this. Great. I think this didn't change. 30 millimeters. Alright, remove him. This is the scaled up version. I want to take a copy of it and to paste it here so that we don't lose him. So then we go back to the original size, or so to speak, to the original one. Scale 90, 95, let's say. Yeah. So 0.95. Fucking idiot. 100. Then if I write here 9, and what the fuck is the problem with that, you idiot? Oh, come on, please don't do it. What the fuck? Is this a fuck? Alright, then fuck yourself. It was shorter, I think. Great. What a lovely program. I don't know how long it was. I think it was supposed to go out till like 75, which is, I think this is what, this was the original one. Yeah, and that's 75. Didn't do too much. Alright, so then we would go to let's go to 12 or 6, sorry. So we go to 6, 7, yeah, and we 15. I think it's supposed to be 15. Maybe it's supposed to be a bit bigger to open the valve a bit more. Yeah, I will make it a bit bigger. We can stay with this size. No, I don't. Is it the inside or the outside that it was problematic? See, but I think it's the inside. I think it's the inside. So I'm actually threading the thread right now, which is kind of funny to see, but yeah. I'm moving the thread up so that the carriage slides. This isn't the best. I think the inside is fine. I think the outside is, yeah, the outside is not good. So the inside is good, the outside is not okay. It should be out with a millimeter or two. Let's go 1.5. Let's see what we can get for that. So the inside is fine. So 6, no, 6, 15, alright. Go here down. Alright, this is fine. Put 1.5 millimeters on it. Let's go with 1.5 mils. Is it doing the same fucking bug here? Yeah, it's doing the same fucking bug, man. I'm writing in 1.5 and it's just taking the first. Them fuckers have. Fuck you. Alright, 1.5 mils. 6. Then this. Alright, going up. Then we take this shit and remove it. Oopsie. Already. Already. Okay, we'll mirror this to the other side. Before that, delete this. If this would alright, no. Mirror. Right, and now we delete the other shit. And now we scale this up to 1. Oh, it will not work. Oh, hallelujah. Ooh. How lovely. So I think it's supposed to be 105 divided by 100. Yes. Oh my god, it works. Great. So yeah, this is supposed to be a 12, not a bigger one, so we reduce this. Yes, because the 12 needs to be reduced. Then the others will be able to go take the same thing. Oh, great! I don't understand why you couldn't find the fucking cylinder. Great, very well. Alright, real thread, select this shit. Alright, we have the real thread, great, save, then hit save to the alternative file format, going to here, reload, it's going to be a bit bigger, I'm going to 100. Alright, reset, 6 millimeters, let's go, 95, fuck, 95, 95 here as well, so X, and I will, maybe it will fuck with the distance here. Unfortunately I cannot take like a reading, or maybe, is this a fucking joke? So let's go. Where does this start? Let's pull it here. This is 10 millimeters. Or is it? Maybe it's not. 80. So it's 80. Oh, okay. So the inside should be 30 millimeters. Which is... Wait a minute. No, I think it was the middle, not the thing. It's supposed to be 20 20 I don't know what, 23 ish. Yeah, all right, that's okay. The outside should be 70, so 35. 1 2 3 4, I mean 1 2 3, and yeah, it's supposed to be 70. What is this? 1 2 3 4 5 here, but I have actually given it 1.5, so that's 2. Is this on the line? Yeah, it's a bit bigger, never mind. Is this the, yeah, yes, we'll see, maybe it will be total shit, utter garbage. Whatever, slice this bad boy, then start printing.
Tanúskodj egyet, mert szólt a csávó, hogy 3-as számú mellékletet ki kell tölteni.
Alright. Alright, so save to disk, print. Alright, we can start printing. I will honestly whatever, gonna come here to the burner. Never. Oh, not this one. So yeah, but the main thing is now that we have a I don't know what the name is. Where are you? A49 88 shield. This, not this one. This one, this green one. This bipolar thing, and what I will do now is that I would want to I will basically set him up. I look for a what is this? Drawing, but I think I have downloaded it. I will do it again. I mean, yeah, it opens it up. Okay, great. So, microcontroller, typical application diagram. So yes, the interesting thing is that I have no fucking clue which pin is which. I will open the package for now. And caution, static sensitive devices not be handled by unauthorized personnel XYX. Alright, fine. Is this supposed to be ripped off, or is this an openable package? I think it is an openable package. Or yes, because there is no, yeah. Yes, just took more force than I thought it would. So, what I will do is that I will make enable my second eye, which is the phone here. I don't know where to put him. I have made another mess again on the build table here, so I will have to make a bit of tidy up first. Alright, fine. Maybe I will throw these out. Made a mess again. Okay. These wires come here. Bunch of fucking wires here. Good. Trash. This is trash, isn't it? Yeah. So, bit of prepping so that I can start doing shit. Alright. What time it is? 9:13. I think it's time to have a coffee. I will go and take a break and make a coffee, then come back. Come back stronger. I am back. I will set up the camera. Need human more. Turn on the heat. And it's about to pop. Or if I flip the switch, that's good enough. Oh great. Yes. Yes, yes, yes. So fixing the camera so that the guy doesn't fuck off Google Assistant. Alright, we have this Droid cam bullshit here. Maybe I should enable droid. Oh yeah. Droid com. Where are we? Hello. Oh no. Maybe I can do Wi-Fi bullshit. Reactivate refresh device list. Activate. Hello. Fuck me. What is this? Or maybe I will have to. Oh yeah, it's working. Great. The other one. Do this instead. Alright, we have the other one here. I will put the what will that? Yeah, as I said, it's a bit of. I will need to fucking vacuum this shit up. Garbage all over the place, man. Unlucky. So whatever. Going to make a bit of clean up here, and we have to do a bit more thorough job. Alright, so we will do this instead. Okay. Alright. Maybe I will put this down here. In the up. Maybe up. Whatever. So the main point is that I have this thing here, which is the board that you can see on the screen. If I am not, I just have to make this a bit better. So I think it is visible now. So here it is. Maybe I will toggle this to the side. Very bad. Sorry. Just we can see here the diagram, but we are not going to use this too much. We use ChatGPT to figure out what the fuck needs to be connected. Because if I remember correctly, we do not need to use all of this, because there is probably internal things already doing these, because there is a lot of with those resistors and things on it. So letting the guy out. This is the heatsink. I think it has like a layer of what is this? Two-sided glue for this tape. I will have to put onto the chip. As you can see, I don't know. Maybe I can zoom in on this. Oh, noob. Sorry. So not this one. So basically, we have this little chippy here that I will put on the two-sided glue. What I was thinking is that there is a lot of resistors and caps already on it, which oh, it is labeled out pretty nice. Oh, great. That's pretty lovely. Direction, step, sleeps, reset. Good. So I will put the heatsink on first. Or maybe first I will ask the guy, ask ChatGPT before I do something stupid. Because you can never be sure. Alright. Summa minima. So we need a I will show him this. This is the picture. Yeah, just as thought. It's inside the thing as well. Be right back. I have to help my dad. But we'll do this. Yeah? So, alright, let's go. Let's see what we need to do here. Getting fucking distracted all the time. Sleep reset, DDD. Either tie them together or both the VDD. You need to first, before yes, starting point 1/8. MS high low. Oh, I see. MS pins, alright, hardwired. Alright, so we start with the heatsink. Make some light here. So how the hell do I put it on that I don't? Oh, I really hope it doesn't. Uh oh. Nah. This is not the best. Because it looks like it touches the fucking. Or maybe if it has this plastic shit on it, then maybe it doesn't conduct. But I'm not so certain about that. Anyway, I'm a bit afraid that we are going to fail. Why the fuck do they have to make it so? Oh, god fucking damn it. Okay, no chat. No chat. What is the what is this? Alright, so we should make the Yeah, it's like 5 seconds of delay. Okay, that's not that bad. Anyway, I don't know. I really don't. I think it will fucking look. How the fuck can you do this so that it doesn't come down here? Basically, that's the good question, isn't it? How do you put it on? Because this shit is here. You cannot really move there. Yeah, this is just a pain in the ass, man. Maybe I suppose I should have put it onto the top of the whole thing. Yeah, maybe I should have done that instead. We'll see. We'll see. Hope the aluminum is oxidated enough or oxidized enough so that it will not conduct. I'm a bit afraid actually that these fucking heatsinks. Man, why don't you put the fucking heatsink on? What kind of dumb product? Alright. So you have here this piece of shit. I mean, the proper thing would be that you put it into a this is a stepper motor driver board, by the way. The proper thing would be that you put into a shield. I suppose I should have bought one of these. Where is this? Is this one? Has like nice little legs. Has even like a thing that you can basically adjust the stepping with, and yeah, it has nice connectors, all this kind of stuff. Yeah, it would be pretty trivial or easy to do this with that. Well, I hope I will not burn it. Besides, we will continue with this. I will look at the chat if anybody wants to talk or something. So we'll put this maybe. Yeah, I think it's good enough. So what I will now do is that come here and want to start thinking how to do this. So sleep plus resets supposed to be on the VDD page is that I will have to move either the whole board here or I will have to go down. But I think I can move the board here. So I will show you the ugly duckling here, which is this big chungus shit. I just don't have enough space here. And it's this chaos. So here is this big piece of garbage. So this is the STM32, which will basically be the controller of this little shit. Which I don't know is that I look for something. I'm curious if this has some sort of pins or something like that. Yeah, because these that you solder to the board, you know, they supposed to be similar or dissimilar. I don't know how this works. They are just female pins that you just solder to the board, but I don't think so. But then, because I have this partially, so we'll make this big. So I have this kit here. I can't show you. Have this kit here that has all these little females, males. Have all these rails as well. So I can actually connect I have a lot of straights. Like, actually, lot. Actually, not lot. This is a fuck ton, I would say. There are even right angle pins like this. So I have quite a lot of pins, though I don't know how I could make this work, because I would not be able to connect the board to this, right? Or maybe I could do it with the, oh, maybe I could do it with that. Maybe I could do it with that. I'll just booting up. So what we do have here is we have the little board here, which I could actually use. This resistor is in the wrong place. So maybe I could put it here. Maybe I could put it here so that we actually do have, but then I would not be able to see the what do you call it, the pin, which pin is which, so I will have to mark it up. Yeah, I will have to mark it up. Alright, take a piece of paper or something. Alright, piece of paper, and now I'm going to write the pins up. Okay. Big Chungus cap on the right side. Right bottom. Big cap at right bottom. So we have 2, 4, 8 pins in a row. Alright. 1, 2, 3, 4, 5. 1, 2, 3, 4. So 8 pins. 2. Alright, this is 4. And we have another 4 here. 1, 2, 3, 4. 2, 3, 4. Okay, and here is the big cap. Right bottom. Alright, so if I turn this up, then it becomes this. So we have actually flipped it. So this, right? Yes, it was there. So this is Waymo. Oh fuck. Sorry, I need to. I'm actually like writing the pins down in order for me to be able to maybe I can connect the other camera so that I will have another camera to show my face whilst I'm doing this shit. At least will show something here. I think this will be alright. Great. So I can put my face here in the bottom somewhere. So basically I don't know if I will be able to show it. No, probably not. Whatever. So the point is that I am actually doing the thing, and maybe I should take this off of here and I will do it here so it will be a bit more interactive, so to speak. I think I'm looking at the chat, so I will be able to tell you. Can actually respond now. I think the stream is set to low. So yeah, we'll mark the pins up. Not the most interesting, but I will have to do this anyways. Besides, V-motor, alright. This is ground or big cap. So if I look at it, this is big cap, and no, I forgot. This is ground. This is remote. Because so this is this. This is this side. 2B, yeah, 2B, 2A. This is 1A, 1B, 1A, 1B. Okay. VDD and ground. Alright, we'll take a look. So this will all be able to control stepper now. So this is the assembly. This here is the assembly. This basically controls a stepper here that we want to control with your board. The stepper actually drives the shaft, and through that threaded shaft, it wait a minute, I will make this sorry, so I will make the whole thing a bit bigger so that so we have this stepper drives the threaded shaft. It drives the air screw that basically will allow the air from the compressor, which is this side. This is the compressor hook. Well, this is the compressor hook. It just doesn't fit in the frame. So this is the compressor hook or the connector, and this goes to the oil gun, which basically atomizes the oil. So this is the high pressure air. It's like two bars of gauge, so it's actually 3 bars. So we have the threaded rod, and when you spin the threaded rod, it basically moves the carriage up and down. And basically here we have an end stop that it stops right after the end stops, so you can't really run it, but the end stop will stop it and clicks, and then it will break the wires or break the circuit, and then when the circuit is broken, the STM32 will recognize that it is broken, and then it will be homed or like approach a bit slower. And basically I'm printing the other part now, which is going to be a bit smaller on the thread so that it doesn't wiggle that much. So yeah, going back to the stepper thing. Maybe I will so cheers, bit of tea. So what do we have here? V-mode, this is this, and this is direction. So this is the deal, step, this is sleep, reset, and this is MS3, MS2, MS1. Got it, damn it. MS1 and enable. No, but alright. So fine. What we are going to do is that I really hope this doesn't condo. Alright. So, yes, on the left, flip it. So this is remote. Yes, this is beer. Beer. Yes. Okay. So, done that. We'll be going back to this sheet. Maybe I should have fucking removed this wire here. Use my cheat sheet, and we are going to plug him in just like how it's supposed to be. Alright, plug him in. Deep. Balls deep. Alright, so sleep plus reset should be hooked together. Sleep plus reset should be hooked together. Oh, ladies and gentlemen, there is a problem. What is the problem? The problem is that you would need both males, right? You need both males, which is not a good idea. Or I could actually make a, but how could I make a stand for it? Now that's the good question. Because I could theoretically do this with male to female or female to male connectors. So basically these wires, or no, this is like females. There is the other bag. Great. I think I have put it back to this bitch. Where are you? Alright, so we have this big bag of female to male connectors. So what we have to do is to hook, sleep and reset to BDD somehow. So basically I think I will do that with a Wagyu, honestly. Probably just the best thing to do. Which I will need actually the female connectors as well. Very well. I have a few of these leftover things here. What the fuck? I have a few of these beat to shit pins, or like 2-point connectors. Probably will need to buy those shorter ones as well. These 20 centimeter ones are pretty honestly annoying. Alright, Wagyu 1. Okay, put it back here. I mean, I don't really need these wires. No, I don't think so. No, I don't think so. So I will take this apart. No. Ah, fuck it. Yeah, we'll be fine. So what we should do is that we should hook together the what is this? We should have a. It's not going to work. And these don't work. How sad, isn't it? Very sad that it doesn't have a pin on both sides, which would be actually pretty favorable. but actually it isn't either, so not that big of a deal. What I want to I think I will need more Vagos than this. Slivan is not enough, so this is the Vago. This creepy bullshit here. How the fuck are we going to do this? So Vago. We need how much? I just have brain fog. I don't know. Maybe the piece of bread. So sleep plus reset should be, which is the third. Yes, that one. And the other one should be sleep plus reset should be connected to BDD, which is that. Which I think, yeah, he would need more than two. And this would not be enough, unfortunately. VDD, I would need a 5-word, right? A 5-word. So not a 3-1, but a 5-1. So the 5-1 has actually one in from the board, one out to VDD, and one out to sleep, one out to the reset, and I think we would be left with one extra port. Or we could technically solder connectors together, but I don't like that. I like to actually use Vagos. Those are so much quicker but more expensive. I would need 2 Vagos. Or technically I could make a 3.3 watt rail as well. Yeah, I mean I could remove this and I could put a 2 rails here, one 3.3 volt and one 5 volt, which would be technically very valuable because the devices that we are going to run are going to be fed from those, and kind of like this. These are bus bars, rails. I would make one of these. That would be the idea, though it is pretty clustered even right now, which we don't have that much tools. We just have what we have. I mean, these little fucking boards like take up all the fucking space and all that. This doesn't look too nice, honestly. What happened to this? I mean, it's pretty solid, so I'm not going to bother with fucking with it. Brown is alright. Okay. So, what do we have here? It's a big cluster, fuck. So, how the fuck are we going to connect these pins, honestly? Because I would need 2 Vagos to connect these, but I would need a long 5 long Vago. Maybe I will go down, find 5 long Vago. Yeah, maybe I will do that for now. Maybe I can solve it later. No, I have to go and find Vago like that. Probably I will need another one. What will I need? I think we need to hook the ground as well, which will, I mean, it would be great to take the ground from here. Yeah, we do even have one. I mean, if this is connected to the board, then we should be able to take the ground from here and to basically take it from here and put it here as well. Because this is kind of like a common ground here that shares basically connects everything up. Because it is connected to this, connected to the other one as well. Maybe I should use this and make another ground here, because I like to tie them together kinda, because then we would not be needing to fuck around with the other dumbass grounds. So this is kind of a useful thing. What I want is, I don't know, hook it there. I hope I will not make a ground loop or something. Because this way it is kind of useful, because you can see that we made like a lot of ground here. We need is this in the frame even? Yeah, it's in the frame. So we have 1, 2, 3, 4 grounds that are common, as well as like I mean everything is common basically to this. So this is like a star ground here. I would make a cable, because then I would not need to take a ground from there, which technically I could, because there are still pins, but I'd say it's better to have plus. Yeah, we need the plus, which I don't have actually, which is kind of shit. Yeah, plus wire will be needed. Technically, this could be fed from here as well. Yeah, I would need to make a fucking a boost bar for this. I think the next two things that I'm going to print is going to be the legs for the screws, as well as I'm going to make boost bars or boost bar holders, and I will cut copper strips here, because this is like pretty annoying that I need to always come up and I'm always lacking fucking connectors, because there is like I mean at least this has like duplicated pins, so we have one female and one male ports of 5 volts and 3 volts as well, which is really spot on, and I like that. We have also a lot of grounds, which is like lovely, but what I would say is that what I don't like is that we don't even have enough pins so that we are able to do all this, even despite of all this lot of pins. So yeah, we'll need to make a boost bar for a 3 volt and for a 5 volt connector. Yes. So yeah, 1.5 Wagyu. Hello, I'm Mesringer, and I am working on this thing here. That you can see this cluster of wires. This is the STM32 and the controlling board. This is the chopper, which controls the basically a blower and a pump, which we can have the one wire here. The main thing that I'm doing is this here in the background, that is pretty small. It is the stepper motor controlling, which controls this bad boy here, this one. No, sorry. So this thing, which is the stepper motor, and we have this screw, just it's pretty small. So this is the whole thing here. Get the carriage and all that kind of stuff. For now, I will take a little tour to the garage and will find myself a few wagons so that I can connect the pins together, because there is a bit more pins need to be done than you have the capability right now. So if you have a bit of patience, I will come back in like 2 to 3 minutes, or maybe you can hop back on. Cheers. So we'll come back in a break. Alrighty, so I'm back. G left, unfortunately. So, whatever. I have found some pins in the garage, or in the yeah, downstairs. So I mean, I can put them here. So I have these five slot levels, which are the, so to speak, reason why I run. So what do we need? We need to hook the guys up, which is red, I would say, 40. I think these are the pins that we have. Let's say we put it here. I think this is the other one. So we have 2 pins, which is so no, so we need one. Yeah, we need one of this. So I don't need one of this. I don't need the others to be famous. I think I will steal the 3.3 watts from the nail header, which is probably the better idea. I put a black thing on this. Why some reason I was taking. So we will put this here, as it actually was. Maybe I should use the orange one. Who knows? So this will be somewhere here. Which one's the always fall down? So what we need is these female to male. I need 2, actually 3, because we need to power the VDD, the sleep, and the reset as well. So clear this. So yeah, 2 orange or a red or purple as well is fine. Thank God there is none of the above listed. Fuck me. Yeah, there's none of these available at the moment. So what I am going to do is that I'm going to choose the purple because oh hello, here it is. It's actually closer than I thought. Okay, so blue wire, purple wire. Alright, probably I need grounds as well. So I'll put this here, put this here, and then we are going to so red 40. So I am hooking up the motor controller board with limited things. I mean, I will adjust the camera a bit so that it's in the frame. I'm actually doing this little shit here because it would be pretty hard to do it the other way. Meaning, if it were that. Can I zoom out? No, I can't, sorry. So, you can write something in the chat if you would like to ask something. I think I am. Oh, hello. Alright. Yeah, I am actually making this. So I am actually making the stepper motor controller, which is this guy here, the stepper motor, and stepper motor. We have the carriage here. The main attraction, or maybe the main thing is this. This is this screw that basically adjusts a compressor outlet, so it allows air from the compressor, which is this lead, and the other lead is goes to the oil gun, basically that sprays the oil or diesel or whatever fuel into the combustion chamber. And basically the compressor air is used to atomize or break down the fuel into very fine mist, and that is easier to ignite than just pure liquid. So yeah, and I'm hooking up the board for it now, if I have the drawing. So step, I think it was reset, sleep, and VDD. VDD is this. This is the VDD. Yeah, VDD is this, and need more things. So yeah, I am making the motor controller for that, which is going to be driven by this microcontroller here. This is the microcontroller board, which is the STM32. It's kind of like an industrial version of the Arduino, or ESP32 if you are familiar with those. It's in the other blackboard on the cardboard box that I'm working on. Come on. space here. Alright, fine. And I am hooking up these wires so that I will be able to do this here. Maybe I should have, I think it was the third or fourth pin. I have to check. Sleep, if it's the third pin on the right. This is the fourth pin. And I will hook this up. And the next one is the third pin. Just it's hard to do the other way, so I will do this instead. So this is the last one, I hope. Maybe I should have done this the other way instead, right? Because it's going to be a bit shit. Then do this. Put the put this to the second pin. There's not too much space in here. Right. Okay, that's fine. Okay, so this is done. What we need is to hook the other pins. Loop or open. What do you mean? Is it like closed loop? Very good question. The burner is going to be or the stepper. Do you mean the stepper? The stepper is going to be feedback from a I do not know. I think it's going to be feed forward, so it's going to be always calculating the next step. I think it's how actually what do you call this 3D printers work, kind of like my Ender 3 that is printing here at the moment, printing the next the carriage, because the current one is pretty wibbly wobbly. I think it is going to be feed forward in that sense that it always calculates the next move. So basically now I'm at step X, let's say 10, and I want to move forward and so on. So it doesn't have a feedback in this sense. The burner is going to be a feedback version, so it's going to have some feedbacks like pressure sensors and all that. So maybe I'm just going to show you here. So this is the guy, and we have a I don't really have any output. Maybe the pressure from this, then there is going to be the pressure hooking up. Yeah, there is going to be the pressure. Basically, I hook this lead to the oil gun, which I don't have here because it's dirty as fuck. So and we can measure the pressure on there, which will be kind of proportional to the opening of the needle, because this is like a membrane needle valve here that the stepper drives. Basically, the stepper is here. It drives a threaded shaft, and it moves this carriage on it. It's kind of wibbly wobbly right now because this is the first prototype, so it is pretty shaky, but still works. As you can see, if I turn it, then it lifts the carriage up, and then basically with this you move it up. When you want to home it for the first time, you basically just move it down, and then it's going to be kind of like the like end stop on like a 3D printer. Is going to hit this end stop here, or clicks, then it's going to come back a bit, then it goes back slower, and it clicks, and then it's going to be zeroed out, and then it's going to know when it is, because that there is backlash and all this bullshit happening, so it might really need to zero out before every it will need to be zeroed out before every test, but yeah. And I will hook this up to the STM32. Just making the little board, I'm hooking it up, and then we will be able to test it out from some so yeah, that's what I'm planning. Right. So I am done with the maybe I will set this to I don't know, see the chat, but for now I will focus on this a bit. So STM32 GPIO. Okay, we will need a pin that is going to be. Do I have? Oh, I have. Alright. So we have this, and I will steal some GPIOs from here. I don't want to use a. I think I will use some of this. There is a lot of pins here. Maybe I will use one of these, but then it's going to be a bit shit. I will use this one, which is. I'll use this one. I'm going to dir direction, which is the right hand. God damn it. The right hand, or yeah, left hand top. Maybe I will put this a bit here. That's fine. There. I have the STM32 Cube IDE, and this basically is the compiler. But I'm going to admit I'm not writing the code. I will need to learn the syntax myself. So I usually write the code with ChatGPT, and I debug it from if it's not working. So I'm going to now learn the fuck off with this. I'm going to write the code with ChatGPT and then debug and basically iterate and to have the compiler. We'll minimize this shit. So I think it's in C, but it's in C, but it's designed for STM32, so it has kind of like this weird syntax, or I mean, I think it is kind of specialized. I'm not sure, but I think so, because there is this whole GPIO and all this kind of stuff here that I have never seen before. Maybe I'm just noob in C, which I am actually, but these are kind of like specific for the STM32 family, I think. Oh, not this one. And basically you can, I don't know if you can, yeah, probably. So you can see the code here. I will make the window even smaller. We do not care about that right now. So basically you can see here that there is this programmer, and you can edit the main C, you can include and call the libraries, and then you enable ADC, which is, you know, reading the analog to digital timers for basically this STM32 is very good because it's kind of like the Arduino, but you can configure it so much. I don't know if you have heard about it. It's so much better in terms of like capability. It's a bit dumber in that sense that it doesn't have Wi-Fi and all that, so you need maybe like a additional board. Fuck off with this. Close this. So it doesn't have the Wi-Fi and Bluetooth as like this board here. I mean, now it would be beneficial to make this a bit bigger. Oh, sorry. So, but there is this black guy here. This is the ESP32 based. It's kind of like an Arduino Uno, but it's ESP32 based. So that is the microcontroller. It has like Bluetooth, Wi-Fi, and all kind of stuff like that. But it is dumb in that sense that it is more unstable. It is less robust because it needs to run all their libraries in the background, and you cannot really configure it like that. Just as I will show. I mean, open it. Let's go into the small side here. So we have the MX, which is basically the compiler. You can choose out the pins here, and what the whole experience looks like is that you have wait till this renders. So I can see the whole STM32 chip here that I have. This is the 446RET. Basically this just a lot of numbers, but it means that this is the F family, which is kind of like a intermediate level board, which is not like the blue pill or the black pill, which are kind of like a lower end in computing. That all comes down to how much pins it has. That is basically here, how much legs it has, how much things it can control at one time, how much these are the clocks, which is basically how fast the thing is running, kind of like with RAMs or like CPUs. I mean, CPU technically. So it's kind of like with CPUs, but it is running at 180 megahertz, I think. I have to check. Yeah, 180 megahertz. Here, this is the core clock. This is the main thing. So yeah, so basically here you can configure all the pins that is on the chip, and if you don't need them, then you don't allow them, so you are not enabling them. So basically when I will plug the enable, which is this, and or the direction, sorry, which I will be controlling from here, which I can configure just like with the SP32. Every board, basically every pin is different in terms of calling it, but it basically they can do a lot of shit. And I'll come back. Not for long. I mean, I have been doing this for, with this embedded shit, I think it's like one month. Yeah, around 1 month. I have bought this. I made like these little circuits with reading thermocouples and all that, but it wasn't that that big of a how do I say this thing in terms of difficulty, because I just took like the Arduino. I mean, I have bought my first Arduino I think a year ago, but I didn't really learn much stuff again. Yeah, so I have to go now to help my dad a bit. I think it's 5 minutes, so if you have the patience, then you can stick out, or you can basically have a coffee or something like that. But this embedded shit is very interesting. You can do a lot of things, and what I have learned now recently is how to integrate like this is a pressure sensor here that I use to this is a very small pressure sensor. Basically he is a 2 plus and minus 2 kilopascal pressure sensor, which I use for this blower here. Basically this is the blower. So blower guy controlled or like driven from a what is this 12 volt brushed DC motor. Have this output with this long pipe, kind of looks like a potato gun or something. This is basically a measuring device here on top. You can have two pressure outlets, and basically between the two you measure the pressure difference, because there is a orifice plate in here in the top, and basically the pressure drop across it is proportional to the amount of volume
metric flow, so basically how much air you are providing with the blower. And I was fiddling around with testing the blower output out. So yeah, I will now go down, help my father with something. He's doing some administrative shit. I hope I will be able to come back. I think it's like 5 minutes at max 10, but I think I will come back pretty soon. Alright. So hold on or grab a coffee. Igen?
Ugye föl kéne mennünk egy üzemanyagtankot visszarakni.
Ez gyönyörű.
Csak üres, föl kell nyomni csak. Oda van rakva. Csak nem bírom föl is nyomni, meg rákapatni a hebederre a anyát.
Jó.
Gondolom Liliné nem fűtöttél be.
Nem.
Csináltam semmit. Kacsáknak kívültem a melegvizet.
Mennyit csináltam? unfortunately nobody's here. I mean, understandable. Whatever. So going to turn this off. Oopsie doopsie. I forgot to adjust the... Oh, it's not that big of a deal, thank God. Alright, peeling off the new print. We'll deal with this later. What I've been thinking about is that I just wanna just want to be free. Right, so this is the new carriage. We'll deal with that later. Now I want to measure out how long the screws need to be, cause I will need to make a few legs for this shit so that we will be able to fit it later. Okay, carriage is here. This is here. I need the screws, which I don't have here, of course. Okay, I need the screws. Actually, I'm gonna put this aside for now. Alright. Oh, god damn it. Alright, one is enough. So, we have this here. If I remember correctly, this is supposed to fit. Or maybe not. Maybe this is too big. This is too big. Huh? Not good. Not good. This is M3. Maybe this. Maybe this. Too big as well. What the fuck? That's not good. What is this? Oh my god. No way. Fuck. So that's not good. That's not it. I'd say M3. Do I even have M3 boards? Maybe. Here is. Yes. I have bought a few one. M3 boards. Not too lovely. Come on. Okay, great. This is the full depth. We'll have to check this thing. So how long? Oh, fuck. Yes. So the other unfun fact is that we need to. Where is? Okay. will need the Ewing. Need this the other way. I don't think this will be long enough, so I will need to probably print. Great. Need to probably print. Is this a fucking joke? Right. It looks like I don't even need to. Yeah, I don't even need. I won't even need the other things. Hope this shit will fit into the thing. So actually, I'm putting together this. How do we call this? Stepper motor. And oh god damn it, these little M3 screws are very annoying. Is this straight? I don't know. I have two on the opposite side, and I think that's going to be fine. Alright. Great. Now this shit is on. We do not need more. We'll put the back into its place. And then we will pull the screws back. God. Damn it. Maybe not the best idea. Unfortunately, I do have this fucking what do you call it? Tendon. Hello. Tendon injury in my elbow, and it's not the best. Let's see. Okay, looks nice. It actually does fit, so the head doesn't push into the oh, maybe not a good idea. I will take this off. So I have the new carriage. I want to put that on top as well. So I will not assemble it. I will just have it so that I will be able to take it off. Or take it apart for now. Then we do not need this. Don't need the screws either. Yeah, don't need this either. Okay, screws here, fine. So we'll come back and work on the step pad control. Alright. Alright. Step pad control. Okay. So, where were we? A bit of coffee. So, step STM32 GPIO. DIR, that's also a GPIO. What do we want? We don't want. I will go with the white one. Go with the white one. Maybe with this. Ah, this is a finger. Alright, then we will use this. Is the other pin of this wragged? Yes, it's wragged. Alright, fine. So yeah, another GPIO will be used, which is going to be this one. And that's going to be the direction, which is the top. What? DIR direction step. Step by step is next to the direction, alright? So it's supposed to be this. So this and they basically good to great. Enable STM active low. STM32 GPIO as well. So we need another GPIO. Another. Fuck. Black. Do I have like blue or something? Let's use blue. Which is enable. I think that was the top right. Okay. Enable pin. It's this, I think. Yeah. Enable. Okay. Okay. And what next? VMOT is motor supply, 12 volts. Is this a good idea? God damn it. So we should take 12 volts off again with a different pin than this. Maybe I should put this to here and bend this a bit. Yes, we can put another screw on there. If I have, oh, I have another one. Oh, good. I do have a few more extra screws still left in the tank. So yes, I do have this, and I will need a pin like this. And then I will need a wire, probably the need this as well, the wire. So what do we have? Don't need this, don't need this, don't need the pins for now. So we don't need the wires. I will put the whole thing aside because I'm maybe. I need some orange cable or something like that. It's pretty useless. Either this brown or this dumbass. Oh, I have this wire, but I think that's too low. I will need to go out for a hunt. I will need red wires or something like that. Because I have this yellow orange wire, but this is not flexible. So that's not good. This is too thick. Yeah. God damn it. Never have the wires I need, man. Sucks. Sucks cock, to be honest. Check on the fire as well as like I will want to find some wires. Any wires here? Nothing. Yeah, fine. Go and find some wires. Need a snipper. Need a snipper. No, Bricky. She's on. Hello, Bricky. Alrighty. So, alrighty. I have got myself a bit of wiring. So yeah, 1.2 amps is not something to take lightly. So I will use this wire, which will come here. This is VMOT, I think, if I'm correct. Right, that's VMOT. GND. Yeah. So maybe have it here if I want. Yeah, let's see. This is good enough. Alright, put the rest into the epoxy. Okay, I will need this. I will need 8 rounds as well for the motor. So, blanking down the wires. Is this a joke? I mean, I can take this down, fine. Alright, don't care, don't care. Maybe I do care, I don't care about this. Yeah. Alright, I don't care about this, we don't care about this either. Let's go here. Is this a fucking joke? Great. Yeah. Looks like this shit isn't strong enough to charge the fucking phone up. Great. Because it's not in the fucking pin or what? I think it's not strong enough in terms of charging. Oh, god damn it, man. Whatever. Blanking down the wire now. I need a male pin. Oopsie. Is this a fucking joke?
the camera just died. Yeah, the streaming phone is basically is just very bad in terms of battery and the. Is this a fucking joke? Goal. This wire is not long enough, for fuck's sake. Oh, I love it. Right. Probably not the best. I'd say it's good enough. Alright, fine. How is the phone doing? It's just not it. I will have to find it. Oh, hello. Be right back. I am here actually just need to swap my phone out because for some reason the battery died on this bitch. I mean, yeah. The battery is not the best, let's say. So I am Mastringer and I am making a device
called the motor controller, as well as like a lot of things. This is a stream of me doing the necessary work to make this little guy here basically working. This is the stepper, and this is a needle valve here that drives the stepper drives the needle valve, which drives this carriage that has this little end stop on the other end, and it works kind of like a 3D printer, that it drives the whole thing backwards and forwards, and you can control the needle valve, which basically allows compressed air into the oil burner's air gun, which is more like an oil gun, which is a device that breaks up fuel, whether veggie oil, diesel, used motor oil, whatever you have, into fine droplets. And I am fixing the camera because my phone died, and where did I put my phone? Okay. So if you give me a few seconds, you can ask questions in the chat. I'm actually I can read it right now because I'm just droid cam. Yeah, then fine. Droid cam. So making the droid cam work. It was quick. Continue droid cam. Hello. One 1.100. Oh, change the fucking thing. Alright, we are back. We are back officially. Yeah, I don't know, how bad is it? Right, let's see. Because the other camera is a lot better, I think. My phone is not the best. Yeah, it's not the best. Yeah, the other one was better. I will need to charge up the other phone. Yeah. Fine. So I will. Alright. So I have actually added this wire, which is going to be the motor. This is pretty solid. Right. So VMOT motor common ground with the STME VMOT mandatory bulk cap ground and VMOT ground with the STME sleep dir enable hardwire or leave default CS below. Come on. Yes. Yes, I think I should connect the 3 pins as well. Ground and I think common ground. I think this is supposed to be driven. Yeah, this ground goes to. We need the ground from here that goes to the ground to here, which I will disable this and we'll put this with that. Yeah. So I will need to make another wire like this. Alright, fine. Vmod. What is the we'll have to find which one is the oh, I see. So alright, so out A, out B is going to go towards the okay. So the problem is that, oh, maybe, but I don't think that's the case. How is the end? Oh fuck, this is not good. This is the dumbass. Oh my god. Yes, I think this is this. And this goes to that. We need VDD, we need enable dir MS1, yes, we need ground. We have a ground that is supposed to connect to, yeah, because this has ground plus 12 and the in out in, yeah, I think that's continued on the next page. Yeah, this doesn't help at all. So yes, so we have, where is this fucking fucker? So, oh hello. I am actually now fiddling around here and trying to figure out which pin is which, because now I want to hook up to the thing, and tier 1, tier 2, SAMs. Yeah, I think this is out, but this is only 2. This is very annoying. How the fuck is this connected? So we have this, that there is enable dir ground 2B 1B VDD, but what? 1A 1, I don't understand. 2A 2B, so 2 out A. Fuck me. Sorry, just confused a bit. One thing you must still do before powering the motor: set the current limit, VREF, do not skip this. Before first motor power, VDD only logic, measure VREF with a multimeter. Turn the pot slowly.
start low. Oh, maybe I need to turn there is like a little pot meter on this, right? Yeah, I think they talk about that. This is VREF. Can I adjust this? I can turn this. Oh, one bad thing is that this done. I should have put the thing a bit further away, because now I can't turn the. Oh my god. Can I do this with something? Then I need to find a fucking small screwdriver for this. Ah, god damn it. Test motion. Sleep plus reset. Hi. What's this? So I have seen this video. It's the same. Oh. Oh no, wait, this can do that. I have one of these. So I have one of these fuckers. So you can basically put this on a pin and then you can yes. Let's see, I have this one. Yes, this works with the DuPont. Okay, and basically I can connect here what? A wire. Screw. Let's just turn in. Oops. Oh, this is very useful. And this would be very useful.
but this is not the right one. Uh, mm, fuck. Fuck off. I need like a wiring diagram. Maybe it would be great to watch this video. Alright, this.
RS is the used as VREF equals IMAX multiplied motor with an A4988 driver along with an Arduino. To start working, we need to set the current limit for the separate motor, which is done.
Yeah, I fucked up. I should have put it to this to the side. Oh my god. Very bad. Maybe I should take it off. Yeah, maybe I should take it off. God damn it.
Done by setting the reference voltage that is VREF on the driver. For the A4988 driver, the formula used
What a lovely.
is VREF equals IMAX multiplied by 8 and multiplied by RS, where
Nice.
IMAX is the maximum operating current of the motor winding, and
Yeah.
RS is the resistance of the current sensing resistor.
R100. We'll see. Oh, great. Yeah, I probably should have not put this shit on. Fuck. Maybe it was RF. It's not here. Do we have a picture of this shit? Probably not. Ah, great. Fuck me. Yeah. This is why I wanted to. Ah. Where is that? Where is the big one? Oh great, it's next to this shit. Oh, great. Is it on the same side? It's on the same side, so it's supposed to be the... Is it on? No, it's not this one. It's supposed to be under this. Fuck. Come on.
On the driver board. First, we find out the motor current.
Yeah, I
For this,
know.
we go to its data sheet and look for the value rated current or current.
Yeah.
In my case, it equals 0.7 amperes. Now, we find out the resistor resistance, RS, by looking at the marking on the driver board. In my case, it says R100. R is a decimal point and 100 is a number after the point, which means that the resistance RS equals 0.1 ohms. Next, we calculate VREF using the formula.
Great. Then I will have to fucking take down the little bitch. Let him off. The problem is that I can't. Which is it? Is the
0.1 and 1.
is
In my
the
case, it's
is the one that is closer to the big cap, so it's the above one. this didn't stick too well. The big cap, so 0.10. Point 10. It says it's 0.10. Very interesting. Can I use the multimeter to measure out the resistance between the two things? Maybe not. Maybe not. Maybe 0.10 ohms. It's a very low, small amount. So I am working over here. 200. Even 200 is too small. Yeah, probably even 200 is too small. This is amperes. Oh, 3. Point 3. But it could be lower. Is this VREF or is this the which is this?
It says R100. R is a decimal point and
Yes.
100 is a number after the point.
I
Which
have
means
point
that the
1.
resistance RS equals 0.1 ohms.
Yeah.
Next,
RS. This is the RFs. Alright, I am actually just finding out what the fuck this is, but yeah, 0.10 ohm. It's not. So, yes. I'm actually finding out how to fucking use this little board, this board here, which is basically the 84988 or something like that. I took off this fucking heatsink shit. we'll have to adjust the pot meter as well on it. So we'll have to find a little thing. I'm just figuring out what to do. But I assume this is 010. Right. Okay. Paul will fuck. It's not too interesting, but this is what we need to do. I need to find out. Basically, I've watched this tutorial video here. I think this is it. So basically, so basically, we have found out that yes, we do have 0.01 ohm.
Next, we calculate VREF using the formula. I recommend that you take not the full rated current, but only 80% of this value. This is necessary because excessive heat may be generated by the driver and the motor itself.
Great.
Inaccuracies in the resistors. So,
Yeah.
take 80% of 0.7 amps with...
So, we calculate that. 0.8 times 1.2 amps, because that's the thing that is rated for. It's 0.96, alright?
56 amps. Now we multiply this value by 8 and multiply
Yes, multiply it with 8, then we multiply it with the
by the resistance of the resistor,
0.1
which, as we have determined, is 0.1.
times 0.1 ohms, 76 something.
As a result, we get 0.448 volts, which must be set on the driver.
Mhm.
To set the reference voltage on the A49
Great.
driver, we need a screwdriver, 2 dial clips, a multimeter, a power supply, and of course the driver itself. Take
Alright.
the screwdriver, attach one end of the first alligator clip to it,
Mhm.
and attach the other end of this alligator.
Okay, great. Painful, but this is what is necessary. So then I will put the heatsink on top of that. We'll put this aside for now. So I will need to find myself a what is this? A small enough screwdriver that we can do this with. And I will take the board and I will go up and find something that is maybe useful. I will need a little screwdriver head for this. So I am back. So yeah, I have got myself a tool that I can twist the potmeter shit on it. I need to find the alligator clip that had. This was it. Yes. Yes. So basically, we can put this on here. Maybe on the other side. Yeah. It was this. I will take this off from here for now. We don't need him. So we need this. We need the multimeter. Alright. Okay. And what do we need?
Clip to the positive probe of the multimeter. Connect the second alligator clip to the negative probe of the multimeter. We connect its other end to the GND pin on the A488 driver. Now we supply a logical 5-volt power supply to the VDD and GND pins on the driver. After that, we turn on the DC voltage measurement mode on the multimeter. Begin to carefully turn the variable resistor on the driver, touching its metal part with a screwdriver, until you get the reference voltage you need, which in my case is 0.448 volts. The driver is now configured and ready to be connected.
So then so much so for the work here that I have just done. You don't need to use this shit. How the fuck do we alright, so then we are just going to put the board back. Put the board back, put the thing heat shield shit back. Fucking one. No, Bushy. Mi van a csík? Na, apa. Kiengedhetem a kutyát? Mi puszad? Jaj, de hogy ez nem rám. So Én?
Igen.
Ja.
Hol vagy?
Fönt.
Gyere enni.
Jó, majd mindjárt megyek. Oh, come on. Mm-hmm. So we can use a VDD 3.3 volts. Alright. Oh, fuck me. How do you set this shit? I don't want to. Maybe I can do this with the legs, but then now I have to take the whole thing apart. That sucks. Come on. Fuck off. Where is this shit?
First 0.448 volt screwdriver. E-pins on the driver.
Alright.
After that, we turn on the driver.
So basically this is facing towards us. So we will put the things here. Yes, we will put the things here. So it would be worth it to push this in, and then VDD is this. Why the fuck is this soldered in the wrong direction, or like this is not written in here? What a shit. Green bitch. Alright, fine. So if I look at it from the top, and yeah, so basically this is this oriented that side. So yes, the VDD is the second one there. So VDD, which is let's go with the red one here. 3 volts goes in here. 3.3 volts. Alright, fine. Yeah. 3.3 volts. And the other one is the ground. Great. So yeah, 3.3 volts. This is this. I need the ground, the common ground, which is not this. Yeah, I need to make a common ground, for fuck's sake. I need to make a common ground first. Fuck. I need to make a common ground. Or that how is he doing this? So basically,
negative probe of the multi-alligator clip to the positive probe of the one end of the first alligator clip to it and attach the other end of this.
so basically, yeah, one end is so. One end of this. Where the fuck is this? So we need to connect the screwdriver.
Attach one end.
Yeah, we need the screwdriver. We have one end connected to the alligator clip. We hook it up to the red this whatever. Yes. All right.
First alligator clip to it and attach the other end of this alligator clip to the positive probe of the multimeter.
Yes.
Connect the second alligator clip.
Yes, we use the second alligator clip to connect to the ground. The fuck should I put this so it doesn't fall down? Bitch. Annoying piece of shit this is. Have no fucking space whatsoever. Great. So I need another alligator clip.
Clip to the negative probe of the multimeter.
Yes.
Connect its other end to the GND pin on the A4988
Connect it to the other.
driver multimeter. We connect its other end to the GND pin on the A4988 driver. Now we supply a logical 5-volt power supply to the VDD and GND pins on the driver. After that, we turn.
So basically, we put a parallel connector to the. We connect a parallel to the. What is this? I would need a. This is power cable. I don't need this. Do I have a? Why would this work? I don't have a goddamn alligator clip. We need an alligator clip. And then the other end would need to connect to the. Oh, maybe I do have. Maybe I do have one. Please, please, please. Oh yeah. Alright, so we do have this. Okay. Okay, we have these, and I need a ground cable. This is too thick. This is too thick. Where is this ground? Not this one. Is this it? No. Where's the fireball ground? Fuck. Is this? Aha! This is it, but this is too short, I suppose. Oh my god. No way. No way we don't have a black wire that is. This is shit. This is short. Nothing is good. Hallelujah. Fuck. This is a bad joke, isn't it? Oh, come on, man. I don't have a damn fucking. Because this is not long enough, right? This is not long enough. So we will need to connect the ground to the yeah, we will connect the ground, yes. So we do not care about that. Connect the ground. We have male. We would need a male. Yeah, we would need a long wire. Fuck. This is not long enough. But I did have a wire that was. Where the fuck did I put that from? I specifically remember that I had one wire that I did not. That I did make, and it was a male-ended wire. Where the fuck could I have? Where did I put it? Not here. It's not here either. Great, now that I need the thing, I don't fucking find it. Unorganizedness. Fucking hell. Is this too thick as well? Is this thicker than the green one? No, it's the same caliber wire. I don't need this big wire, for fuck's sake. I don't need this big thick wire. I don't think I have it here. Alligator clippy wire. No. This is shit. Not good. Copper strip. I do have these brown wires, but this is too short, yes. This is too thin. This is too thick. This is too short as well. We have solid wire, but I am afraid that the solid wire is not good. This is what I just brought, I think. This is as thick as the other one, so it is not good either. Yeah, this is the same thickness as this one. For fuck's sake. I don't want to use solid wires. I don't want to use solid wires. This is too thick as well, even thicker than this. Not good. Solid wire, pipe. I don't know where that fucker could be. This is a white wire, but this is very thin. Red wires, not good. This will be used, this won't. Can we use a thick wire or a... No, can we use this? Let's see. If I put it under the thing, then technically we could use it. Yeah, we could technically use it. Don't like the solid wires. I will need to go out again, for fuck's sake. Where is the pliers? polgárfinter. Jó van, Bőcsi. Itt van még apa? És van? Alright, so I got back the got this back. Put this together. And fires. I think I got this. And I think this will be fine. Right. Yeah, this is a bit too short. You have to see. Well, I think this will be alright. Yeah, it's alright. We'll need to take the. Yeah, we'll need to make a. Alright. Crimping. With a male connector. Actually, this is only the third male connector that I use. Didn't really use too much. Alright. Yeah, could have been better. Not the best crimp I've ever made. Alright, put the wire here. Take this out. Tomorrow I will make a fucking. I'll tidy up the whole place. This is getting kind of shitty. Need to take this out. Alright. We'll put the brown here. Somehow under the things. We need to put a heat shrink over it so it doesn't break. Oh great! Oh great, you started living on your own. I'm living on my own. Oh great! How lovely. This is a pain in the ass. one goes in, the other goes out. Fucking great. Did it stick now? Alright, it did. Alright. This is power, so we don't need this right now. VDD. I'll put the heat shrink on if I can find it. Great. At least it shows it is nice and strong. How long should this be? I think like this. Where is this? Not this one. Or do I will put one on that one as well? Come on. Go into the fucking pin. Alright, fine. This is ground. And what do we need? The other pin to be connected to. Yes, this is very shitty. The other one will need to connect to this. Yes, and we will need the other clip to go into the black one. And I mean, it would be alright if I could put a jumper in here, or maybe I could take the reading from here, but I'm afraid that this will not fit. And yeah, probably the voltage will drop as well. So maybe I can take a black wire like this and take the voltage from the behind, from the back. Alright, fine. 3.3 volts, black. This goes on to here. Doesn't even connect. Great. Good start. Such a lovely start. Maybe should connect to this. This will connect to the negative terminal of the multimeter if I can fucking find it. Na jó, hol voltál?
Megnéztem, hogy fönt vagyok-e.
Remek. Put this here. I don't think this is connected. Alright. Does this connect to the right? Not the best. Where is this little shit? Alright. Put it to, let's say 2 volts. Then we fire up the guy. Then we pin output. Is this still going? Alright. Then we will remove the camera because I don't have enough USB cables. Alright. Oh great, it's in the small. Oh my fucking god. How lovely. Well, I mean, I haven't done too much anyways. So think a bit. Just wanna see the studio. So, right, fine. All right. So what do we do now? I will check that I didn't connect the power to it. I don't think so. Okay. It looks decent. This is this. This is supposed to be I think this is supposed to be 3 volts. This is connected to that as well. Same line. It's this is the ground. This is the ground and this is VDD. Alright. So it's supposed to be right. It's supposed to be alright. So ground is connected to that. Also we take the ground from here. Alright. I hope it will work. So I will unplug my camera. We don't need that right now. And I will plug in the USB thingy. And hopefully we will be able to not fuck the whole thing. And but how much I should set it? 1.7. So 0.7. Let's go to if I set it to 0.64, 0.7, that's 0.8, 0.64. I will go with 0.64. So alright, we are 0.1 currently. Am I turning this? Yeah. 0.2, 0.3, 0.64. .64 now. Alright. 0.64 is just before. Alright, it worked. Very well. So 0.64. Yeah, 0.64. Yeah, it's a bit lower than what I originally wanted. If this is, let's say, 0.768 equals
1.2 amps times 0.8, which is I don't know what. Then 0.64 equals x times 0.8, which is, how do I get it? So 0.764. I mean, everything is linear in here, so it's supposed to be if we divide this, so if we take this and we 0.64 divided by Ctrl V equals 0.83 times 1.2, which is about 1 amp, supposed to be, but it probably will be lower. So if this month checks out, it's 0.8 amps. Alright, that's fine. Alright. Okay, now I will go back to watching the video. So
Other end to the GND pin on the
yeah.
4988 driver. Now we supply a logical 5-volt power supply to the VDD and GND pins on the driver.
Okay.
After that, we turn on the DC voltage measurement mode on the multimeter. Begin
Yeah.
to carefully turn the variable that we turn on the DC voltage measurement mode on the multimeter.
20.
Begin to carefully turn the variable resistor on the driver, touching its metal part with a screwdriver, until you get the reference voltage you need, which in my case is 0.448 volts. The driver is now configured and ready to be connected. First, we connect the DIR pin or direction pin to one of the Arduino digital pins.
Mm-hmm. Okay. So we use the direction, so I can take the whole thing off, turn off the multimeter for now. I will take off the whole setup. So the guys did their job very well. Don't need them anymore. Right. Okay, need the wire. Okay. But don't put him today too far for now. He will be needed here. Take the multimeter, wrap it up. So, what we should do now is that I will take this out. So we are connected to ground very lovely, very nicely. Put these to the side. We'll need to set and enable. And now it is the time to code. So basically we have these pins, which will be what? We need direction, which is this. So direction. This is the big thingy, big capacitor in the bottom left. Yes, direction is top right. If then, so direction is top right. I have actually reversed it. It's supposed to be. Maybe I will swap. I don't give a fuck. So yeah, this is VDD. I should connect the direction, which will be this pin, or I don't know, maybe this, because this is direction is the top right. So this is direction, I think. Yeah, I think this is top right. So VDD is the opposite. 5 volts red. This is the VDD. This is ground. Yes, and we should put a bulk cap here. Yep. Alright. I will need to find one bulk cap.
For example, D2, and the step pin to another digital pin. For example, D3.
Okay, so yes, these are the step and the where are we? So we have it in the top right corner now. So yes, direction step. So these two, let's say I have the blue one, the first blue, which is this, which is going to be the this is yes, this is this. We use two of these. These will be the you have to find a fucking drawing. We'll need to write these down. So on myself, I don't really care about my head for now. What do we have? We need the F4 as this pin out, embed all right. Not these, I need the outside this. We have this, I think these are, yes, actually the fourth, from the fourth up, so 1, 2, 3, 4, PH1, PH0, PC15, okay. PC15, that's PH0, PH, oh actually this is VBAT, alright, so I have been lucky. So PH1 is the PH1, PH0, alright, PH1 is what? PH1 is what? That's the direction, I think. Yes, that's PH1 there. There, okay. PH0 is the white one, which is going to be the step, if I'm correct. Yes, step, and the I think this is supposed to be either enable, whatever. Let's continue with the video.
Now we connect the reset and sleep pins together.
Okay, reset.
To use the internal pull-up resistor of the sleep pin, which supplies a logical 1 to both pins, thereby bringing the driver out of sleep and reset mode for immediate operation.
Alright.
We supply 5 volts to the logic part of the driver by
Okay. So basically,
for immediate operation.
We connect the two ends, or two ends. We connect the, which is this, sleep and reset. Alright, that's fine. Sleep and reset is connected together, which I need a pin for because I don't have a male wire. We need to crimp one up. It's not too long, it's not too short either. So we'll use this or something like that. How long is this supposed to be? I don't know, this long. Is this? Yeah, probably. Okay. Cut the wire. Okay. Cut the end from here. Need 2 males. This is the great about these crimp set, because I can now basically just make jumper wires myself, which is, yeah, sure, if I had the solid wire,
that it would be better in that sense that I could, you know, use the solid wire as the jumper itself. I wouldn't need to crimp all these things and just cut the solid wire, which I actually might will do, so that I will be able to do that in the future. That would be a lot easier rather than just having to crimp up these random ass. Alright, this got to be pretty good. Pretty solid. Okay, one end is done, with the other end. Uh-oh. Okay, fine. So both ends are nice and alright. To put these in here. Good. Alright, these are done. And then we connect to what? Yeah, we'll need to connect up the...
To use the internal pull-up resistor of the sleep pin,
Yes.
which supplies a logical 1 to both pins, thereby bringing the driver out of sleep and reset mode for immediate operation. Then we supply 5 volts to the logic part of the driver by connecting the VDD pin to
Yes,
the 5-volt pin on the Arduino and the GND pin
To
to the
the gu-
GND pin on the Arduino. For
yes.
stability, we also connect a 10 microfarads electrolytic capacitor.
10 micro.
The next step is to connect the stepper motor. Also connect the 10 microfarad.
Micro. I think the micro is the UF. 10 UF. I will need to find UF. What size of bulb can should I use? $100 UF, 200 UF, electrolytic, at least 35 volt, safe choice, plus 100 NF ceramic in parallel, also close. Alright. So I will need to find the caps. We'll need a 35 volt. I think it's not here. Or maybe 85 volt. These are resistors. No. Bunch of fucking resistors, but I don't need any of them. Great. It's not here. There is the other box. No. What? Where did I put them? cable here. Yes. I don't have any. Nope. I don't have any of these here. Okay, fine. So that maybe in the box. Maybe it's in the box itself. Yes, it's in here. This big bunch of fucking capacitors here. Need to find a 220 UF 30 volt. Alright, this is great. We have one, and that is okay. And short push, no. These are not those. Alright, 100 UF, don't care. I need the little ceramic fuckers. Nope. No. Oh, here you are. So here they are. And put this back to the box. Maybe I should take these out so I don't need to open that all the fucking time. Put these in here. Alright. Okay. Put the nails back in here. Okay. Pretty well. So what we will do is that 12 volt, a 12 volt gives more margin. We have the guy here. Maybe I will cut his legs. This guy I will need to solder the little bitch. These are the caps here actually. Where is this? So here they are. These little 3mm caps. I will solder one between the two legs of this one, and then I will put the guy into the I will have to find out which leg should go into which pin, but regardless I will you know what, I'll put the guy back. I think what I will do now is that I have basically been able to do this. I will take a launch break and then come back. I will take a launch break and then come back. So yeah, I will put the wires back to the side. The wires are here with these random ass jumpers here. I'll put these here so that I will find them. Tool. Don't need these. Oh. Wire. These, I don't need these. But I need the bubbles. I'll put the bubbles here. Alright, so I will take a break now, and I will basically just stream this whilst I will eat, and then I will come back.
Already, so I'm back in this bitch and delete. Oh, I mean, but what is this? Yoink. Make this smaller. Oh, not this one. Sorry, just. Oh. Right. So let's restart this, shall we? So, yeah, where were we? I was actually hooking up the motor controller, this, which I will use to control the NEMA 17 stepper, and now we will go back and watch, continue, or maybe I will stop this shit. Stop this and listen to this video.
Electrolytic capacitor.
Yeah.
The next step is to connect the
We
stepper.
can use this. Oh, yeah, that's what I wanted to do. Actually, I was wanting to solder the thing. Oh, fuck. So, soldering. Okay. Okay, here is the guy. Here is the G-mat. Okay, here's the guy. I don't know, maybe like so. No, oh, fuck 'em. Fuck these wires. Or so I will pivot a bit. So I don't know. Is this visible? Oh, fucking wire, man. I mean, it's not that big of a deal. We will continue, and I will now. I will do. Yeah. Yoink one of these caps. Okay. Yoink one of these caps. And this is a bad joke, I'd say. Maybe shit. We see. Little fucking piece of shit. There was this big one.
Alright. I remember this bigger. How the fuck did I... Very annoying piece of garbage, to be honest. Honestly, this is a pain in the ass. Heat up, baby. Now what? Now this shit itself too? Is this in the connector? Oh please God. Oh yeah, it's working. Fine. Alright, it's fine. Alright. It is fine. Or is it? It looks alright. not the best, but it will be fine. Maybe I should have put it closer. I will cut the legs a bit. Where are you now? Between VMod and oh my god, it's supposed to be there. Great. Yes. Okay, so negative to ground, which is actually the opposite of how it's supposed to be. Then we should remove the guy, flip him. Maybe I should flip the whole thing, because then it would be easier to, because the negative is supposed to be in here, but then the fucking thing will not be good. God fucking damn it, I need to take the whole thing out and then so if we turn him, then which was here will go there. Alright, so the whole thing that I have just set up is not good, but that's fine, that's alright. We'll do the ground and we'll put it here. VDD is supposed to be here. Ground supposed to be here. On this side, if I am correct. Let's see. So, what is this? Big cap. Oh, alright, that's good. So yes, VDD is that, ground is that. Alright, that's fine. These will be these. So I will need to put the enable pin to, yeah, need to put this to the furthest, which will be this. This is the direction, whatever that is, this is this. So blue goes there, which is, yes, this is direction, which is that. A step is the blue, which is pH 0. Alright, we connect the two guys here. Take this. Oh my god. Fuck. This should be above it, not under it. Yeah. Supposed to go here. Alright. Turning back here. Can unpower the guy. Alright, these two motherfuckers are connected. We do not need him for now. We'll think through which pin will be used to what function, but this is fine for now. Put this somewhere. Wait a minute. But if I only connect 3 things, then I could use a 5 volt if I don't need the 3 volts, right? Then I could use a 2 strip. So basically this can be removed because this is not used. This can be removed as well, and that's fine. And technically we could actually get away with only the 3.3 volts shit, which is this, if I put a thing on it. So I wouldn't even need the whole thing to begin with. So basically I could utilize this pin instead of this pin, and take this and put a thing on it, put a, not this, the little black shit, this black shit on, 3.3 volts coming in. Alright, ground as well, these are as well, this is in, alright, this is in as well. Great, now we have everything except the bulk bullshit, which is going to be here, which is basically the ground, which is this one, and the other one, which is the other one. And actually turning it the other way around didn't have either, so okay, put it in. Oh, oopsie doopsie, I really hope it will connect. We'll try it out with the multi guy. I actually put the cap too low. Maybe I should take it apart and then assemble it a bit further up, because now the thing is just held there. Yes, this is the BP mode. This is supposed not to be, yes, this is not connected, but if I take this and this, then we are connected. This and this. Okay, okay, this is not connected. Great. Alright, so that's good. Okay, how are we doing? Fine, let's come here and switch the video.
Stepper motor itself to the driver board. To do this, connect the 2 groups of motor windings to the first and second groups. There are 2 ways to find out which group is which. The first is the simplest. You will only need 1 jumper and the stepper motor itself. First, try to rotate the stepper motor shaft with your hand. It should rotate quite easily. Remember how easy it was to rotate? And now take your jumper and try to short circuit the 2 terminals of the stepper motor windings. After that, try turning the motor shaft again. If the feeling is not significantly different or has not changed at all, disconnect 1 jumper contact from the winding output and connect it to the other contact. Repeat this procedure until the motor shaft becomes significantly harder to turn. Now separate these 2 outputs from the other contacts and connect them to the contacts of one of the groups, namely 1 or 2. Let's say I connect them to group 1 and the other pair of contacts to the other group. I will say right away that if you connect these contacts in reverse, for example, the stepper motor will simply rotate in the other direction. The second method involves using a multimeter. Turn on continuity mode, take 2 probes, and connect both of them to any contacts. Then move one of the probes between all the contacts until the multimeter starts beeping. As mentioned earlier, connect it to the driver. The last step, the multimeter starts beeping.
So, continuity, we need the board, or the motor itself, sorry. So the motor itself, and should connect the wire, if I can find it. Where are you, wire? Where the fuck did I put? Ah, here it is. Alright. Okay, connect the guy. So let's see. It is supposed to go in one direction. So this way. This is fully seated. So let's see. We have this wire here. We have continuity mode. Alright. So I suppose the red and the black is no. So red and blue. How the fuck should I? Red and blue, and the black and the green. Alright. So basically these two are the two groups. Okay, fine. Alright, and how the fuck are we supposed to do this? So we would need two, oh fuck me. This is the problem. So turn this off, take this. So yes, the two next to each other are the two groups. So what we should do, somehow connect this to somehow connect this to these. Which is which? 1A, 1B, 2A, 2B. Actually they're supposed to be, yes, on the same. Yeah, so basically they connect here next to the VDD and the ground. That's it, and the V-mod is fed from 12 volts, which is between which two pins should we? Oh, I think I fucked up. Oh, cause yeah, this is V-mod and ground, not the power and this. So this is supposed not to come here, but to come here. Right. So which one is which? So yes, V-mod is plus, and the thing is minus. This is minus. V-mod. No, this is supposed to be here. So this side one is the V-mod, and the inside one is the ground. So basically this is supposed to go this. Okay. So put the V-mod here. Put the GND here. Oh. Alright, fine. Take this, and maybe I should have split this into two halves, whatever. Okay, and then we will take this, put the minus to the minus, and the plus to the plus. Okay, fine. This could be put here if I had the fucking pins long enough. Oh. Do I have the... Oh, maybe I have a few of those. Maybe those can, but maybe not. I don't think that they are long enough. Though it would be very good. But I suppose, yeah, they are not going to be long enough. For fuck's sake. I will need to make 4 jumper wires, for fuck's sake. Fuck. I will need to make 4 jumper wires. Great. I need to make a board or something so that it's not going to be on this shit all the time. So that I will be able to connect it with females. How the fuck will I be able to do this? I suppose with jumpers. I don't know. I do not know. So what do? We take 2 batches of wires. We don't need long wires. With the black one and the red one. Both of them are black, but one is black and yellow, the other one is black and red. I don't know. Not too long. Yeah. Alright, so where's the snipper? Oh, fuck the whole thing. So, ow. So actually, I don't know, is this visible? Not that much. Maybe I will do it here. Okay, and let's use this as an ettalon. Okay, so these are done. Hello, where is the last? Oh, here they are. Just gone. Alright. God damn you. Okay. Fine. One is done. Good. I need to cut this off. Not this one. And the fuel penalty thing. Bitch. Fucking hell. Yeah, the end is shit for some reason. Still not good. This is a joke, isn't it? Fuck yourself. Come on. This is a fucking joke. Not again, man. So we have him. Need the crimper kit. Let's take out some mil connectors. I don't need. Is it 4? I don't need 8. Yes, because of 4 wires, 2 ends. Yeah. I don't need 8. 1. Whatever, I have 150, so I have plenty. We have plenty of wires as well. 2. Besides, I can reuse these little shits later on. 3, I think. Yes. 4. Come on. Yeah. God damn it. 2 more. Right, you can put in the music. Nimbus. Nimbus. Inbox. Fuck all. Not again. So 1, 2. I think this is too small again. 1, 2. Great. God damn it. Great.
Fine.
Yeah, this is so much worse than having just little standard wires that I could use.
Whatever.
turn. And the last one.
Mi ez a hang?
Mi van? Ennyire unatkozol? Felszabadítod a Tónit? Izével, mi ez? 6 méteres szállal? Vigyázz, mert ott magad mögött meg lehet összetöröd a Tóni. Vagy az a tető? Az mi ez a jégtelenítő műszer? Tóni letakarítása. Fölülre felszerelünk a spritzelőt, ami etilenglykolt fog benyomni a felületre. Fölülre beszerelünk a cselet, az etilenglykolt leengedi. Mondjuk jó sok kéne belőle, hogy elolvadj ez a szar. Amúgy nem tudom, hát nem. Itt már egész jó kiolvadt a tetején. Ilyen téli helyeken azért csinálják ilyen nagyon meredekre a tetőt, hogy lecsúszson róla a hó. No. Alright. So, oh yeah, I will turn on the lights because I can't see just shit. Or not too much at least.
Burby. Okay.
Win.
I like this.
All right.
Come, where you piece of shit.
Maybe I'll put him to the 3D printer. No. Hopefully this will not fall down. All right. So we have the direction 1. Is this? I mean, yeah, should put the heat shrink on it because it might be getting shorted or some bullshit. So I don't want that. Did I use up the second one as well? Whatever. Plenty of this shit. Plenty and even more than that. So, where is this? How long this should be? The need for that. Oh, fuck off, come on, go on to it. Okay, we have 4 little nice jumpers. So, let's see. We need a ground. Maybe we could make a jumper as well. It's common anyways. And yeah, then I would need to make another one. ground jumper. Alright. I think I will need to make another one. Fuck. Whatever. Ground. Yeah, maybe I should have not. Let's say this one. I need another batch of 2 plus nail connectors. Bacon. Hummus. huh? Alrighty. So what do we have here? Not this, I need the VMod ground. Yeah, 1A, 1B. So basically till the ground we have all 4 connectors, 1A, 1B. So let's go with A, that's going to be the positive, and so we should take from the, yes, from the power, we should go with black, black, red, red, black. Alright. So black, red, red, black. Alright. Black, red, I love this. Red, and finally black. So let's go with this. So red and blue. Red is maybe worse, whatever. Maybe should have done this a different way. Oh, for fuck's sake. Oh, I'm not using the right one, okay. This is going to be the red one. Okay, they don't touch. Looks pretty decent. At least this. Okay. Okay. Maybe I will put a let's see. I need to enable the pins, so I need to put this somewhere different till I can figure out what to do with them. Maybe on the print back here, or maybe behind the whole thing. I gotta find it fine as well, if I can fit him here somehow. What the fuck is here? Fucking wobbles, man. Okay. Now let's see. Have done the wiring finally. I'm pretty tired from this shit already. So let's see.
As mentioned earlier, connected to the driver. The last step is to supply power through the driver to the stepper motor. To do this, connect the VM pin to the power source required by your stepper.
Oh, we should connect the ground and the 3 volt as well with the bull cap.
Motor. In my case, it's 12 volt.
Can we use remote ground remote? Do we It goes back to the STM32. Yes. Alright. So we need this 100 NF plus bull cap, 10 UF, ceramic, electrolytic. 4.72. I have to find the fucking caps again. I really hope I have 10. Where are the? Oh, I think I put it here. 10 NF. That's not good. We need 10 UF. Fucking diode. We need 10 UF, not 600 UF. I really hope I do have them. That sucks if I don't. 100R, I don't need these. 170 PF, useless. 47 UF. This is the smallest I do have. Not the best. Fuck. 470. 47. $470 NF, 100 NF, 100 NF is too small. It's hot as fuck in here. I need to take my hoodie off. And 470 NF. Do I have? No, I don't think so. I think I just have the big ones. I do not have the fucking. Oh my god. The smallest I do have is 47 UF. Is that good with the 100 NF?
fuck's sake. Yes, fine. Near the A. VDD pin. Alright. Object polarity ground to ground. Ceramic doesn't matter. Alright. Okay, we go. Matteo. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. These fucking shit. I think this is visible now. Not too much. God fucking damn it, man. Everything is in the fucking way. Ah, the fuck you that there is no spacing to build this little fucking table. Divider is not long enough. Great. Whatever. So have to do the same fucking thing again. Just now with the this looks decent. Use this. I will need to stack these fucking 100 MF bitch little capacitors up again. Because I have used a lot already. I think I only have 4, 5. Yeah, I wasted one technically, so whatever. Unfortunately that was the learning one. At least now I have a semi-viable route, which is basically I soldered the little caps to the legs. I've seen you, bitch. Let's heal.
fucking electrolytic fuckers. Fucking hell, man. Perfect. Turn the light off. Alrighty. My back. Yeah. Cutting the legs off here. Here. Oopsie, oopsie. Now, hope it will be long enough. This is the ground, this is the power. Fuck you. Come on. Random ass fucking pieces falling into my PC. I don't like this. Thank God it was not the electrolytic, so. That means that we are fine for now. So yes. Okay. We have him. Yes. So let's check with the multimeter. Alright. Multimeter. Oh. Or maybe because it is the ground. Huh. VDD2. How the fuck is that? Oh. No way. We have a short. Where? We have a short circuit. Or do we have it wired through the motor? Hope only this is just the motor. But that. Oh no. What did we do? But it didn't fucking click. Yes. This is the ground and this is the this is this supposed not to beep. Yes, but this not supposed to beep. What are we doing that is not good? This is the 3.3 volts. This is supposed not to beep with anything. Oh my god. If I remove this, maybe this thing is fried. This cap is shit, maybe. Yes. Does the legs of this connect? Pet. Oopsie. Fuck you, man. No, this doesn't connect. But then what the fuck does it? I don't understand. This is ground. Yes. Ground. Ground. Ground to ground. And if I take the ground and put it into the electrolytic, this so this is not beeping. Then why the fuck was it beeping then? This is ground, this is ground as well. Alright. That's okay. I don't know what was it. I remove nothing. Nothing fancy. Is there... Yeah, okay. So I've used a jumper from the What the fuck do you call this? Not buck. The what is this? The chop pan. That feeds the
Van mocskos gúnyád, mert anyád akarja mosni.
so be right back. So I'm back. Okay. What do we do now? Motor. Busz.
Itt már mit a videós óra?
Given also have choppers on this one. Busz as well. Plus 100 NF. What pins should the end stop? What pins should the end stop be connected to?
close. Come on to ground. Yes. And the two will be NC HTML out to 3.3 volts. And the GPI that supports input to tool X8 interrupt must be nem pillanatban.
Nem is akarsz segíteni, eszedbe sincs, hogy segítsél valamit is, mi?
Mit?
Hát, hogyha itt csinálom, kecsölöm neked a szájba baszott zuhanykabinodat, te nem csinálod meg magadnak,
Alright. What do I want? Wanna find the PC15 pin. Here it is. Oh fuck. Low speed clock, crystal ceramic, not good. Then we will remove this and move it to PH1 PC0 PC0 is fine as well. We do not want to read the analog. PH1. Should we do the PH1? Because it's not configured here. Or is it fuck? It's in. Yeah. So these pins are all taken away. PC2, PC3. Yes, PC14 maybe. PC14 9 either. PC13 either. PB7. PB7, that's fine. Which is actually under the ground. Oh, it's actually next to the ground. PB7 is next to the ground, okay. So we configure this and put him next to the ground. Is the first ground, I think. Fuck off. PB7. This is the 1, 2, 3, 4, 5, 6, 7, 8, 9. 9th pin. So 1, 2, 3, 4, 5. Right, yes, this is the 5th, 6, 7, 8, 9. Right, fine. Okay, PB7. PB7. GPIO output. I think it was. Yes, force a safe state of the reset. GP out push pull. Alright. GP out output 7. Pull up, output push pull. Alright. Default state at boot, set it high. GPU output level high disabled until your firmware is ready, then pull it low. However, PC15. Oh, I see. So driver is disabled when it is this. Yeah. Okay. Default state yes. However, PC15 is not a great general purpose output, yes. Yes, yes. And stop. Input pull up xt is usually okay. Enable pick something. Yeah. Whatever is free. We need step. Step. Driven by a timer. Enable. Yeah. Okay. GPIO output. The direction is GPIO output. Okay. Dir is I think PH2, PC2. GPIO output. This is a GPIO. I think it is a GPIO output as well. I think this is the PC is the lower one. We have to check, but I think PC no, the PC3 is the direction. That's the first thing. Yes. That's the dir. PC3 is dir. User, no, not this one. The PC3, this. Alright, PC2 is step. Okay, PB7 is what was PB7? I think that's enable. And all right. Normal GPIO. GPIO output. Dir. GPIO event out. Maybe GPIO XT3. Step. Or maybe limit switch XT. Timer interrupt toggling. Change that from real timer champion. Okay. So step should be PC3 is there. I think it's the lower RAM. Yeah, this is there. Step is PC2, which is the white one. Yes, and should be moved to where the fuck is this? PB6. Oh, fuck you. Is this fucking serious? PB6 is on the fucking other side. PA15. I don't want to put the thing on the other side. If yeah, I think these are not good pins. But these could actually be used. PB, yeah. PD, PC, PC, PC. Yes, I guess PA15. Where the fuck is PA15? Oh, I probably will not be. Or maybe it's just not. Ah, here it is. I think this is because PA15. We wanted to set it to timer 2 channel 1. Yes, I suppose. And this will be the GPIO, yeah, timer 2 channel 1. And this will be in timer 2. Slave mode, timer enable. Input, output, compare channel 1. I don't think this is PWM. Remote switch, yes, pull up, raising edge, single NC, make it go when pressed. Exit interrupt. Yes, I think we did this. Dir on, this is not good. Dir is not on PC2, you dumbass. Or then maybe I fucked it up. Whatever, PC is on this shit. No pull, pull, no pull. Push, pull. We'll go back to GPIO. deer. Ah, fuck. Alright, this is okay. PC GPIO output. What is this? Yes, GPIO output, great. GPIO mode. PC to GPIO mode output. Outpush push pull. Yes, pull no pull. Pull down. How the fuck do I set it no pull? Yeah, no pull up and no pull down. No pull, no pull. So set push pull, no pull. No push, no pull. Oh, I think this is what he means, that there is no pull up or no pull down. Okay. User label there. Okay. Option A. We should place it to different. Yes, GPIO output. Yes, push pull, no pull, low speed. Yes, ID. Yes, I've done this. Push pull, GPIO output. Okay. Debounce method simple, reliable. Method 1 recommended. Ignores edge is for 10. Yes. Record last. Oh, okay. Okay, using a timer to generate step pulses. Option timer interrupt on PC. Pick a timer not already used. Timer 3 or 4 are common examples used. Yes. Interrupt driven step clock. Enable timer 3. I will use timer 2. Enable external clock trigger source. Clock source, internal clock. Clock source, internal clock. Set prescaler period to get your step interrupt rate. Yes, we will have to set that. Enable team global interrupt in NVIC. NVIC settings. Enable team cat to global interrupt. Alright. Yeah, we have to set the team timer. Yeah, I don't care about this. PWM step. Yes, PB6 timer. PB6, where the fuck is PB6? I don't think that's going to go. Okay, timer for channel 1. PWM. Okay, then we set to PWM generation. Okay. Save external clock output PWM generation CH1. Okay. And then we do step rate duty 50%. Start stop stepping. I will set the thing. Where were you? Counter. No. Interla. Auto reload. Prescaler. Yes, here it is. Prescaler. I will set this to 999. Oh no, this one was 3 actually, and the other thing was ARR or something like that. This was it. ARR counter period. This was 999. Internal clock. CH polarity high. Fast mode. Pulse mode. Trigger event selection. So I have set the what is this?
PA15. Left the deer on. These are the settings. These are the settings I have used. Pulls. Set pulls to 500. Okay. Just maybe 50%. ARR, okay, prescaler to 89. We need, yeah. Okay, pulls 50, 500. Okay. It's not a problem if it is, but I will turn the step here out. Yes, and name this to what is this? GPIO PC PA15. Why the fuck isn't it here? System yeah, Tim. We'll call it step. Alright, PA7. Whatever, we don't have a name for that. I think PA7, PA6, what the fuck did they do? PA7, PA6, PA7, PA6, oh, PA6, PA7, PA6 is the, where the fuck is the number? D10, PA6, yeah. Oh,
Was it fuck? That's P B P A. So that's 12. 11 is the 7. Okay. So the 12 is the green, which goes to that, and that goes to. Who is this? The green one. Blue goes to chopper. This is the blower. So this is the blower. The upper one, which is the green, is the blower. So 12 is blower. So 12 is blower, which is PA6. PA6 is blower. PA6 is blower. The other one is pump, PWM. Okay. Okay. Push pull. P15. System core. Yes. Sys. Debug. Set to serial wire HVD only. Serial wire. Serial wire HVD only. Yes. Raw PI is freed. Okay, PA. Move and steps, then stop using the interrupt you enabled. Whatever, I will update the code now so that we don't lose all these fucking settings. I will take a snippet and then okay, we have the new code inside this. We have timer 3 should be another timer 3 USR2 dear GPIO port LTD dear and all right. Team channel 1, team channel 2, yes, timer 3, but this is timer 3. MX timer 3 in it, or maybe this is the timer 2, ah yes it is, here it is, timer 2 in it.
Okay. Mm. Oh, fuck off. What the fuck do we call this? What do we call this? Not PW. What is this? The stepper V1 boom. Oh, fuck off. Fuck. Damn sticks came out. Alright. Okay. There is no... We will initialize it then. Alright. Okay. Okay. So, let's go with this Necrotech. Alright. GPI when it says N high. Good. PB7N. I think so. Yes, PB7 is N. Dir pin is set as output as a default. Manage PC3.
User code begin. Volatile. Mhm. Mhm. Team 3 PWM Pulse. Yes, I know. Yes, I know. Move steps. Yes. Enable. Odd. Mm. User code 4 begin. Ja, nem. Right. Begin 4. Error. Volatile. Mhm. Mm. Test the move on to the
You sure about that, bro? Button. Yeah, it's really PA5. Okay. Pull up, rising and falling. So yes, lead, pin. Okay. Okay, push pull, no pull, low speed, generate code, temporary test. Ensure latch starts off. Optional. Pin 5. On the XC, yes, I wrote this into the code begin for. Alright. Right pin, geo, pin 5. LED on, alright. This is going to be going into the section. Well, wait a minute. Volatile Hall GPI Waxy callback. Yes. Oh yeah, he wrote it into the thing. Okay. Okay, static. Yes, last MS. Now Hall get class 20 debounce. Set reset. Okay. S equals GPIO pin set. Pin state S. And say to ground, pull up, pressed, reset 1, release, reset 0. What? Switch? Shut the fuck up about this switch com middle ground. We don't have a com, you dumbass. Switch NC, normal close side BP1. Not press PB, tied to ground. P0, LED off. Press PB floating, pull up. Oh. Limit switch pin. Yet XC1. You confirm you enabled XT1. XT1 code end. User code end. Limit switch pin. Okay. This is the user interrupt. Hall GPIO XT. Use code. Yes, I think this is it. Okay. If you still get no interrupt temporal poll in the main loop. buildy buildy. Hopefully it works. It's supposed to. Alright, alright. It works. Great. And says connected to the when the clicking of the switch correct wiring, failsafe. The annual pin is not used. Dodge this. Alright. So, hello. I'm just about to upload the code to the bad boy. We can see the ESP32 here. This is the stepper motor here with the screw. I'm not going to how to say this, move it, because it is connected with this purple pin to the limit switch that is on it, and I want to now test the thing. I wanna connect up the guy. Basically, if you have any questions, you can write it in the comment section. I am happy to yeah, we did not change anything. Let's upload this bad boy. Alright. Connecting, debugging, 79%, uploading the code. Alright, progress. And impact, we are ready. So, what do we have here? MX. If I press the button here, then it's supposed to make the. Oh, you can see that the LED is toggled on the board. Great. So first, good. V1 is working, alright. Disabling him. Impact. Tessék! Nem. Mondtam, hogy nem. Oh, fuck. Oh, bitch ass. Stepper,
V2.
All right. Can you help me? PB1. Alright, okay. CubaMax requirements. Okay, that's fine. Yeah, that's okay. Okay. Unlabel XT already done, limit switch. Okay, these are already done. Yes. Add global helper functions, put in main code. Global. Okay. Hmm. Hmm. Basic GPIO helpers. Static inline. Static void stepper int n. Int right. Static float. Static void. I think this is supposed to be here. Pressure sensor. pin 3, GPIO pin 3. Dir. Configure GPIO pin. Dir pin. Dir. So GPIO pin D, GPIO D pin dir, just dir pin. Okay, just dir pin. Okay. Dir pin. Fuck you. Relay pin dir underscore pin. Dir pin. Dir pin. Dir pin. Oh, not big pin. Okay. This will work. Alright. GPIO B. GPIO pin 7. Which is called N pin. N pin. Alright. Dir. Use those instead, okay? Set hertz. Use this to choose step from console. I would say this is a helper function. Hertz. Right. Buildy. Not used. Alright. Stepper, set hertz. Alright, we will use it later. Start, stop. Stepper, start, move. Start void stepper, start continuous, step hertz. Move steps. Nice. Add this callback user code begin for. Static void step per home. Oh, maybe I should have not done this. Wait a minute. Not here. Where are they? Oh, I will have to write it here. Okay. Stop. Okay. User code and what's this? GPI button. Pressure processing. Oh, this is the. Where the fuck is the? Yes. Slow level access. Robust median. Okay. Set hertz. Step per move. Set hertz. Yes. Ah. Yes. Okay. Step per home. Step per home. Then in your existing GPIO exit callback for PB odd. The fuck do existing call GNU odd if GPIO pin equals 1 static yes uint now static last MS if now last MS return last MS yes pressed 1 this if I mean I can control C the whole thing from if GPIO equals GPIO 1 yes last MS was declared here I think this is this yes yes we do this we take this we build the whole thing two warnings two things are not used uint last mesh oh it doesn't alright one warning you need sep hertz console commands extend your existing parser continuous and stop As if HTTP. Does this work now? Ah, I know. Then what the fuck is the pseudo implementation in here inside your yeah, if this belongs to this if, right? So if I put this here, it's supposed to work. Yes, then what the error is about build might be incomplete. But the problem is as if cmd undeclared first use this function cmd. What is cmd? cmd. What is op? Op and then they think. I think this is not cmd, this is op. Don't know what this op is, but what about now? As if step per stop. Step per home. Oh, cause we need to put the fucking things above this, don't we? Yeah. We need this shit. Step per start, all these fucking things we need. Yep. We need to put these above them. Fuck. Does this shit work now? It will not work because maybe of the fuck off.
Also, the up is a char or character. So basically, we store the data in that. Okay. Team2 interrupt is never enabled in NVIC. Alright, Team2. Team2. Yes. But it's here. Period elapsed callback. Go to NVIC. Is there anything? Oh, NVIC. Oh, I need to also. Oh, okay. But it's. Team2 is global interrupt. Why is Team3 not a global interrupt? RCC. Pinal, generate code. Team3, yes, it's also in here. Alright. Yes, enable. Hall NVIC after Team2 init. Okay. What is this? Team2 init. MX UART after Team2 init. Team2 init. But it's on. ER, it is here. ERQ handler Team2. It's enabled. Hall Team IRQ. After Team2 init. Where the fuck is Team2 init? Team2 initialize. Hall team init. Team if. Oh. Team2 init. User code begin 2. Oh, maybe I should put it. Fuck you. Maybe I should put it here. Hall team start. Yes, team channel. Alright. Set prior or no, fuck. After Team2 init. MX Team2 inish. Yeah, I can't do this because this is not my thing. But maybe here I can, after starting it, I can set it priority. This is the main blocker right now.
Team 2 PWM started too early, not fatal but messy. Remove this line from main. Halt Team PWM start. Okay, then we remove this from main. Main. Yes. HTTP deal. Okay. What the name? Position. Right, there's no more. Let's see if this builds. No, it actually builds down. Alright, I'm surprised a bit, even. Alright, file, save as v4. Okay.
Dir GPIO port. Okay. Dir pin. Okay, GPIOC instead of so basically this is supposed to be in so GPIOC. Oopsie doopsie. Alright, so dir GPIO port, dir pin. Okay. Dir pin, okay, dir GPIO port. Okay. Okay. Enable team 2, update interrupt after PWM start or start base timer interrupt 2. Yes. Before PWM start. Alright, so team enable, stepper enable. Is this it? Halt team base start ET. Stepper move steps. Oh. Okay. Robust change recommended. In stepper move steps after starting PWM. Halt team base start ET. Stepper move steps after starting this. Team channel 1. Team it update. Halt team disable ET. Halt team base then after instead after the PWM. Starting the PWM. Yes, after starting the PWM. Boom, halt team base again. Yes. Stepper stop. Stepper stop after what is this? Halt team base stop after and in stepper stop base stop it. PWM stop. Halt him. Start it. Stop it. Alright. If
if you add halt in base start it. Don't call it. After the two fixes above, try move and did open, move 200, 200. Step home. Great, we'll save this. I will go take a food break and then I will dun, 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 1.22. That's fine. Maybe I should restart it or something next time. Probably it went to shit. Whatever. 1.22. 1.1. What is 1.22? So 1 minute 22 seconds. So that's 82 secs. Times 24. That's this much seconds. Divide that by 60. And this is this minutes. And yeah, that's half an hour. So 0.5 divided by 60 again, which is 0.5 5-ish hours total. Good. I'm happy with that. So whatever. Lunch break. Now we will set this to dinner break. Dinner break, I would say 18:45. I need a half an hour, so we will tune the fuck out. Magnus. Magus. Now it's time. Let's see if this shit works or not. Let's upload this bad boy. Shutting down. COM4. Connect. Unable to do it. Now. Ready. Oh. Yeah, this is annoying as fuck. I think I have indices, Bovartest. No, this is the dataset. Bovartest, main C. No, this is the yes, books. Fuck. Display, no, this is not it. We'll need it from the backpack. Need a pen drive. Alright, so we should take this out, put the other one in, so then I would know. What do we need? This is STM32, and I think this is the either this. I don't know which one it is. Non-blocking. Maybe this is it. This is a trash, by the way. We'll see. Maybe I will make it. Oh, alright. Remove this. And now what the fuck? Great. Whatever, it works. Send. It would be great if you fucking acknowledged alt. So if I press the button here, the blue button, then it should click.
Alright, great. That's okay. Then do this again. Disarm. Now the green LED will turn off. Okay, great. So now I want the I don't know if this thing still connected. I don't know. Did we remove the? Did we remove the? Maybe we need to. What was the? HTTPN. All right. Fuck you. STP enabled. If I put the power on, 5 watts. .6 watts. State 1. Okay. HTTP dir open. Okay, we put the power 1.6 watts. HTTP dir open. Something did some sound. Okay. Step move 200. Nothing. Yes. Nothing is happening. I will turn him off. Try homing. Step. Try homing. Try homing. HTTP home. .6 watts. Nothing is happening. So basically either the current is not enough or something is wrong with the thing, because it is not wanting to run. So I have a strong feeling that the guy is stalling out. So what I don't want to do is I want to disconnect the thing and then find the screwdriver thing, remove the things, remove these two fuckers. No, it's not plugged in. Okay, I understand why it is not working. Alright. Alright, we should remove the guy. Not from this, but from the whole thing. And I will put him somewhere around here. I don't mind that. What is the big resistance now? Alright, so if we have this, let's try this without the thing, shall we? So we should be able to do this. So yeah, run the MATLAB code, hopefully it will connect, please. What? Fuck off with this. For it not connecting, bitch. Shut up. Ready? Alright, printing this bullshit. Send HTTP N or stop. Yes, so it doesn't do jack shit. Okay, let's go with N. Yes, 0.17 amps is going in, 1.6 watts. HTTP dir open unknown. Yes, HTTP move 200 nothing, went back to 0. Not STP stop. It's not about that, something is wrong with the either the wiring. I don't get it. This is ground, yes. I don't understand. HTTP enabled. Yes. Takes up 1.6 watts. Body. One point six watts per nine. sand. Oh, okay. So basically we would need to use this as well. STP run. I'm just gonna try this. Enabled. Yes, goes up to 6. Nothing. It doesn't merge. Actually, when I put the 200, the volt goes down. Or the stop. Goes down to 0. Just one halting period elapsed callback. XT, nope. Period, yes. So basically, and the driver. If if steps minus if team greater than instance team equals to if 50 HTTP running static div equals hard toggle pin GD D is closed, reset, open is set. All GPI read pin. Yes, output A and 1B should be, yes. I see what the problem is. Yeah, I think I know what the problem is. The A1 and... oh my god. I connected it wrong. Yes. I knew this was going to happen. So basically, this is not the right thing. The middle two... oh fuck me. This is the problem. Oopsie doopsie, I plugged all of them out. Whatever. So we would put the red... how the fuck is this? So 1B and 1A. Yeah, the B's should be together and the A's should be together. What a fucking shit way. Cause yeah, 1A, 1B, or 1A, 1B. 1A, 1B should be in a second. 1A, 1B. Yes, 1A, 1B. I'm going to disable this. Yeah, fuck you. No. So we have this shit. If adjust div equals 0, instance equals to static div, if this should be in this, if this is the, yes, this is this. Okay, let's see, does this compile? It's supposed to, right? Then run. If LED never toggles, then team update interrupts aren't happening. Meter. Team to channel 1, it's that. Yeah. Put this fucker onto the board. Upload the fucking file. Okay, connect. Yes, need to. Okay, do it now, please. Yes, all right. And no, not this. Oh fuck. Or yeah, I forgot whatever the
thing supposed to be um, fuck this. Can't see jack shit. STP run 5. Nope. It doesn't. STP run 5. STP move 200 200. It blinks. Blinked for twice and then it was, yeah, it went out. So it was it. Yeah. Dear, this is direction step. Step is this white shit. Oh, wait a minute. That's why it isn't working. I didn't put this to the other side, for fuck's sake. Yes, this fucking shit is needed not to be here. It's supposed to be the, what is this? PA15. Which fucking pin is that? I didn't hook the PA15 up. Is this a fucking joke? Yeah, I suppose it's a fucking bad joke that I didn't do it. Actually. Oh, I see. Yes, because the step is the second wire and I didn't take the, yes, because the step is on the PA15 and that is the, I think that is N. Oh, I see what the problem is now. Okay, I know what the problem is. So yes, the wiring is not good. Yes, this is supposed to not be this. This is supposed to be this instead.
So the white wire should come here, and the blue wire should there. Which one was this? PA15. This is next to, actually this is PA15 is next to the ground. The next to this. Oh, I see what the problem is. It wasn't right. It's next to the 5 volt. It's next to the 5 volt, not to the ground. Oh, hello. So yes, the PA16 is not this one, it's this one. It's actually further ahead. And might be the case that the PB7, which I think PB limit switch, PB7, yes, the PB7 is the N, which is this, if I, or this, I don't know, is the enable on the side of direction, which is this, but the last pin. So not no step, not the sleep, but this enable supposed to be next to the PB7, supposed to be next to the lower ground, basically. So this is going to be the lower ground. Yes, it's next to the lower ground, which is this, I suppose. Yes, because I think that there is a pin in between them. PA15 and PB7, yes, there is this ground pin between them, which is, yeah, might found the problem. So yeah, this is the first, second, 3, 4, 5, 6, 7, 8, 9. This is the 9th pin, right? So 1, 2, 3, 4, 5, 6, 7, 8. Or no, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And the 2 above that is the 2 above that is the is this step. All right. So it's supposed to be working. So yes, this is going to be the ground, this is going to be the power, this is going to be the power, and this is going to be the ground. Well, I mean, it doesn't really matter, to be honest. Alright, I mean, yeah, I probably should not do this. Fuck me. So this 2 goes to that. So this 2 goes to here. So ground goes to this. Come on, man. Alright, and this 2 goes into Is this like a bad fucking joke? What the fuck is up? Why is this so much shorter than the other wires, for fuck's sake? Probably I made this last HIS pin. For fuck's sake, man. Go going to the fucking pin. Alright. So yes, this two goes to that one, and those to those. Alright. So if I put this fucking, I really hope this will work now. Fucking hell, man. Alright, so what is this? MATLAB bridge. Running the code, it will not find it, fine. Alright. And we should send the STP got some power, boop boop boop, N enabled. Something did happen, there was a sound. Move 200, 200, hooray! So it turns that okay, great. How do I turn it to the other direction? Dir open. Okay, dir open. Run 200. Is this supposed to buzz this hard? around still be around 50. Is this buzzing with this even? Around 200. Yes, it's buzzing. Yeah, it's vibrating pretty badly. With 50 it's even worse. Oh. Okay, so yes, we should connect up the micro stepping shit. It's supposed to be all right. Okay, so I will remove this and we will connect the things to ground. Yeah, the micro stepping is wrong actually. Yes, we'll make this better. So yeah, the micro stepping is not enabled. That's why we do have this MS3, MS2, MS1. So enable, next to enable, the 3 pins that we have left open is basically the is basically what we should use. Yes. How the fuck are we going to do this? I think we should use how do we do this? Maybe with the waggle. There was one waggle and I do put the things. So I should make a jumper that goes from here to the other side. Maybe from VDD I could enable the micro stepping. The first one, MS3. I have to check the fucking fuck. Nope. Oh fuck me. It's not here. Alright, then we should find the what was this? Stepper motor with Arduino and
Hello, today we'll control a NEMA 17 stepper motor with an A4 pin to one of the Arduino digital pins, for example D2, and the step pin. First and second. First, try to rotate the step. After that, try to supply power through the driver. After connecting the main circuit, we need to set the rotation accuracy or step division. Micro step control is performed by 3 pins, MS1, MS2, and MS3, short for micro step select. By combining a 5-volt supply or ground to them, we can change the number of steps per motor revolution. For example, if your NEMA 17 has 200 steps per revolution, these settings will increase it. Here are the 5 available division modes for the A4988. For a full step, connect pins MS1, MS2, and MS3 to ground. The motor makes, for example, 200 steps per revolution. This is the default mode if the
I think that's enough.
are not even connected. If you want half a step, connect pin MS1 to 5 volts and MS2 and MS3 to ground. The accuracy increases 2 times to 400 steps per revolution. To get a quarter step,
I mean, I will pull them down for now. What I will do with the... I'll find the little bastard. Oh, I used him up with the... Yeah, here. God damn it. I would need to make... Wait a minute. So we have one that jumps there, one from that jumps there and there. So basically I would need one jumper, two jumpers, three jumpers. Three jumper wires. Oh my god. Yes. What a waste. What a waste. Fuck's sake. God damn it, man. I mean, later on I can use these. Later on I could use these. God fucking damn it. This is probably long enough. The others shouldn't be this long. Probably this will be enough. Is there any space even there? I don't know. How long is this? Ground. Yes, so these cables basically go 1, 2, 3, alright? Dun, 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 dun. Alright, we need the blanker, if I could find it. It's on the ground. Oh great, can't even fucking take off the... Very well. I'm sick and fucking tired of this. Where's the knife? Yeah, I will buy these fucking wires. It's so painful. I will just cut them, blank the end, or blank the wire from the end, and it will be done. Basically, now I have to just make every. I mean, the females are not that bad. I mean, honestly, but these males are absolutely just a waste of space. Holy Jesus. Yeah. Made a lot of jumpers, all this shit for. I mean, I wouldn't say for nothing, because I will be able to use it later, but yeah, if I had the fucking wires, then I wouldn't need to make all these bitch ass jumper shits. So much so for that. Oopsie doopsie. Putting in the think this will suffice. Alright. Only the last one. Fuck me. So slow. I mean, faster than soldering, that's for certain, but slower than just having the appropriate thickness of wire and then putting it into the hose after blanking the end off. That would be the ultimate version of this. Is this a fucking joke? Alright. Oh, yeah, I should remove this, right? Because people might think that I'm still eating or some shit. plenty of this black, but the black doesn't go onto any of the fucking. Alright. And the last one. Setting up a stepper motor is not as easy as you would think it is. Send a few wires up into the microcontroller and you're fine. I mean, are you sure? Yeah. Thing is that I mean, yeah. Mm. Alright, was not a fast process, definitely. I mean, yeah. This supposed to be, this would have been probably like, I'd say, at max 3-5 minutes if I did it with the fucking wire, rather than just having to make wires. Oh my fucking god. Alright. Now let's see if we have made the whole thing work. This, and what about these? So 1, 2, 3, okay. Okay. What? Huh? What the fuck? What? What the fuck? No, the bastard piece of shit. Maybe it was why does it conduct then? Maybe, oh, I don't know. Yeah, it's not a bug, it's a feature. So I should not remove it, maybe it's charged up or some shit. Or I don't know. So yeah. So what? I mean, yes. Hello, I'm Maceringer, and you just caught the stepper test in time, because I've been fiddling around for quite some time now with the making of the wires. So I now will be able to test the stepper, and maybe if it won't. What is this? Yes, remove, enable. So basically, run the MATLAB code. Okay. So basically, I will enable the put the power on. Okay. Enable. Yes. Should put this to dir open. So the direction is open, which I have no fucking clue. And we should set it to move 200. It's actually still vibrating pretty bad. Maybe it's this. It's supposed to be this vibrating, because it's not floating anymore. It's connected to ground, which is kind of interesting. We'll test it out with the end stop, I suppose. If this didn't fix the whole thing, then I guess I will just hook the whole thing up and then start moving it. I don't not give a fuck. Alright, so if you have any questions, then You can ask it in the chat right now. I'm actually. Oh, you didn't see it. I have like a control panel. Oh, whatever. No. Right. I'm going to hook the whole thing. Alright, one. I will just put in two. I don't probably need the rest of them. Okay. Okay. So, what happens if I put the same command? Okay, so it draws this shit back. Okay, so we should disable the thing. Stop. Then set it to stop to dir close. Okay, and we should set it to I think STP. So what is this? So what is this? Use low hertz like 50, 100, step home 50. When you run it, be ready to hit step home. Be ready to hit stop, okay? If anything goes wrong. So basically, stop. Okay. Be ready to hit the stop if anything goes wrong, okay? Step home 50. If it homes in the wrong direction, uses close versus step dir open. Yes, it's right. The open is going up, the close is going down. Okay. Expected behavior. When limit switch is pressed and the exit callback should do something like stop. Okay. Back off dir open plus at low speed. Okay. Let's see. It worked. Let's go. It worked. It's just pretty bad in terms of like very vibrating. I don't know why. For fuck's sake. Alright. Okay, so it works. Just the thing is very slow. Closing is the right direction. Started vibrating even more. GND to the